Welcome to 2021 Smart Manufacturing International Forum today, and I'm your MC for today. My name is Wendy. Good morning.Morning， 大家早安。好，那也欢迎大家莅临到我们今天的2021智慧制造之机械设备安全管理的国际研讨会。我是今天的主持人弯弯。那今天其实很开心了，就是今天可以不用透过镜头直接看到真人哈，就是在我们的实体研讨会当中看到大家。那只是呢，因为其实我们当然还是很遵守这个防疫规定，我们把大家都隔得远远的，有没有？所以大家不用担心。那么另外，其实我们有一些部分的贵宾，他们是直接透过后方的直播线上来收看我们这一次的国际研讨会。那也跟正在就是镜头前收看的所有的观众朋友们打个招呼 ，Good morning, ladies and gentlemen. OK， 那其实我们今天这个活动呢，也是有透过 YouTube 跟脸书 FB 的这个平台上同步来直播，所以大家应该就是可以从这两个平台当中来收看。那今年呢，就是我们第1届的智慧制造之机械设备安全管理国际研讨会。这一场国际研讨会呢，真的非常感谢我们是由劳动部职业安全卫生署来指导，以及财团法人精密机械研究发展中心所来举办的这一场一个在我们的产业非常重要的一个技术盛会。那很荣幸，其实我们这一次呢，也邀请到了几位国际上很厉害的专家们来跟我们大家分享智慧制造安全技术的一些内容。那其实这一次的国际研讨会，除了呢是让我们可以更了解一下，现在在这些先进国家当中，他们产业的一个发展之外，当然我们国内其实也是在这边也是很有我们自己的一个领域跟成就的哈。那其实我们国内当然也有一些经验跟案例可以来跟大家做分享的，所以其实透过今天的一场国际研讨会呢，我们希望借着这个机会，让我们彼此业界也许未来有更多合作的机会跟可能性。那当然在座各位今天也都是我们非常这个领域当中非常重要的角色们，所以今天呢，我也先来介绍一下今天所有莅临的贵宾。那我们首先要欢迎的是劳动部职业安全卫生署的李伯昌副署长，欢迎。好，另外呢，就是我们财团法人精密机械研究发展中心的赖永祥总经理，早。同时他也是我们今天的大会主席。然后紧接着我们要欢迎是劳动部职业安全卫生署的陈光辉副组长，早。谢谢。以及台湾智慧自动化机器人协会的陈文珍秘书长，我们最近真的非常常碰面，非常欢迎你。OK， 好，接下来我们欢迎中华产业安全防灾协会的徐一亮理事长，早，欢迎。以及国立阳明交通大学陈俊勋前副校长，好，谢谢你。接着我们欢迎化学物质危害与环境风险研究中心的高正山主任，早，欢迎欢迎。好，以及经济部智慧机械推动办公室的林松全副主任，早安，欢迎。还有金属工业研发中心的魏远洋组长，谢谢，欢迎。好，接着呢，我们要欢迎今天是我们其中一位讲者，元进经纪股份有限公司苏瑞瑶董事长。好，欢迎，今天也非常期待你的演讲哦。那另外我们还有一位讲者是来自我们这次的主办单位财团法人精密机械研究发展中心，我们的李义生处长。好，他今天呢也会在这个下午场跟大家分享一些这个案例。好，那同时呢，其实我们线上收看的这些观众跟贵宾们，也包括来自新加坡、澳洲在台协会，还有日本在台协会，跟我们一些国内业者朋友，也非常欢迎大家的加入。那么在今天研讨会的一开始呢，首先是就可以邀请到我们的主办单位，也是大会主席，我们欢迎赖永祥总经理来为我们大家做一个开场引言。
李副还有我们陈副校长还有我们陈副组长，还有我们谢科长坐在那边谢科长是还有我们魏兄还有我们这个松全还有文珍还有苏博还有在座的大家早那很高兴今天能够有这个机会大家能够齐聚一堂来举办这个研讨会了 在这个我在回想说我在应该30年前进入我们这个产业界的时候，我那时候还在业界哈，我那时候刚在做机械设计。那机械设计的时候，我们那时候有等于其实就学习了哈，国外的一些机台，然后我只是举一个例子说，曾经国外的机台它用3个极限开关，那时候我们这种粗到小毛头哈，就觉得我用一个很巧妙的设计哈，把它变成2个这个极限开关啦哈，那这样子的话替公司省下了大概800块的成本哈，那非常的开心哈。后来渐渐过了几年才懂自己是笨人家是双回路的安全开关我们只是把人家少掉一个而已，就觉得自己很聪明这个这个就是我们这个安全的第一步的概念那渐渐的，当然跟业界这边接触越来越多了以后，其实很容易在业界的这些前辈们跟他们在交换名片握手的时候，发现他们少了几根手指头的情形，那时候都觉得有一点点尴尬，但其实都是前辈们他们努力的一些算是成果经验他都能细数当初哪一根手指头是在什么状况之下失去的，类似这样。那渐渐的我们就可以更感受到所谓的安全的重要了我想这个当然这几年来我们一直在发展的这些的技术，我们对安全认证这个法规的这个部分当然是越来越严谨我觉得我们也做得相当的不错。这样的情形是在我刚刚讲的手指头的这些，大概是在前辈们的状况之下，那这现在都好很多了。但是这几年来的这个我们现在所谓的发展所谓的智慧机械，过去机械是帮我们来做这个服务做加工，是由我们来操作的那可能因为我们的疏失，或是我们做这个设计上的不安全，而让我们受了伤，让我们操作者受了伤。但是未来的智慧机械，它是有操作的能力，它自身有思考的部分能力以现阶段来讲。但是那这样子的话，我们所谓的人机协同的这种操作的时候的安全性，其实就更加的重要。那这引发了当然除了机械设备本身的这个安全以外，还有治安的一些安全控制上的一些的相关的安全的这个部分，其实就是逐步的这个被更加的一个重视了那我想也就是我们今天要来召开这个研讨会最主要的一个目的了我们也希望能够共创我们这种更美好的一个生活，这个大概就是我们最主要的一个目的。那我们也希望今天的研讨会能够成功顺利好，谢谢大家，谢谢。
非常谢谢赖永祥总经理的一个帮我们做一个开场引言那紧接着呢，我们也欢迎我们今天的这个财团劳动部职业安全卫生署的李伯昌副署长来跟我们大家做一个致辞，欢迎。
好，我们今天的主人那个总经理还有我们敬爱的那个副校长还有那个我们今天的讲者就是苏董事长跟李处长还有我们刚才一早来就很热情那个招待的文珍秘书长还有那个我们高教授，还有徐教授还有各位与会的大家，还有我们林副主任与会的大家早。我在想他们本来帮我准备的那个讲稿那我在想这个讲稿如果跟各位来讲是有点对不起大家。为什么？因为你们都是在这一个方面的一个翘楚那我讲这么多，好像我觉得怪倒是我现在跟各位报告一件事情，反而是我们现在在劳动部跟治安署我们现在目前做了一件蛮重大的而且很艰巨的一个工作，那跟我们今天这个主题是会息息相关。也就是说，我们根据劳工职业灾害保险与保护法，那我们衍生出来我们成立一个叫做财团法人的职灾预防与重建的中心。那这个东西为什么会跟大家有关系那因为这个部分我们现在目前在积极在规划中那这个规划中我们有5个技术服务处，那其中一个我们就设定叫做机械设备技术服务处那这个服务处最重要的东西就在做什么？就是说我们今天对于这些协同机器人也好，或者是说机械设备的一些危害，那造成我们劳工在职场上的所谓的生理性的身体上的生理性的一个叫做失能。那 如果说我们在前端这预防，大家没有帮我们把关做好的话，那就变成会造成我劳工的一个失能。当然死亡就是另外一回事哈。那失能以后，我们现在透过这样的一个重建的制度，我们希望让他再回到职场。可是我们往往在提啦哈，以前的想法在提，就是说我们常常把很多的经费是放在后端，就是说他失能了，那我们怎样去救助他，怎么样去补助他、补偿他。可是我们现在的观念在变，我们希望在前端这个预防这边，对不对哦？那就把它做好。那所以说我们在整个财团法人这样的一个规划上来讲哈，我们基本上是让在前端的这个预防这边哦，总共是成立了2个处。好，那我们希望说以后有很多机会来跟各位来合作哈。合作什么？比如说我们像今天，大概我们官会在哈，我们很多现在请各位帮忙的一些计划案，那都是一年一年的哈。那我们以后期待是说，我们会把这些现在这些相关的一大部分的这些预防的业务，那我们会去移拨到给法人去做处理。那法人的处理跟现在的处理不一样，就是说，它可以跳脱我政府采购法的每年1年1标的这种概念。那因为这个每年1年1标哈，都很浪费那个时间在做文书作业，反而真的去做那个核心工作哈，都是头前督后边村中一点点啊。那我们以后不希望，我们以后希望说，前面的文书作业跟后面的结案作业可以缩短。那真正的一个核心时间，重点时间，放在我们这边的一个预防端来做。那这个是值得我们来期待哈。那也跟各位报告说，这个法人是一定会成立，而且是在明年的5月1号就会挂牌，就会挂牌。所以很快哈，很快。那就跟大家来做交流哈。那当然我们今天也非常开心啦哈。那有这样的一个研讨会哈，那署长也特别交代哈。那本来他今天要亲自来哈，因为被临时通知到立法院做预算报告哈。那他也特别交代说，今天一定要好好跟各位来学习哈。那我们更期待说，今天这样的机会是一个开始。那我们接下来就有很多要请各位帮忙的地方。那另外一个就是说，今天的那个研讨，他们给我看的资料是蛮丰富的了哈。那我们也敬请期待哈。那最后就进入今天的大会成功啊！各位身体健康啊，事业兴隆，谢谢各位，谢谢。
谢谢，我们非常谢谢吕伯昌副署长哦，他是特别以这个劳工职业安全的一个角度来切入。当然，我们在这个智慧机械、精密机械发展的同时，当然还是要回归到我们的人，这个劳工的安全才是非常重要的一个重点哦，毕竟安全才能够走得长远。好，那么接着下来呢，因为我想我们也是难得在这个实体活动当中齐聚一堂，所以接下来我想要借由这个机会，就是邀请我们在场的贵宾们一起来帮我们完成一个大合照哈。那是不是我就再次的简单的唱名，邀请各位贵宾就帮我们来到台前。好，首先呢，来欢迎我们的赖永祥总经理。经机械研发中心的赖永祥总经理是我们今天的大会主席，好，以及我们刚才也是跟大家做引言，我们的吕伯昌副署长，好，接下来有欢迎陈光辉副组长，好，也是来自治安署，好，接着呢，欢迎我们制动协会的陈文珍秘书长，还有徐一亮理事长是来自中华产业安全防灾协会，帮我们站在前排的位置是。好，接着呢，我们也欢迎阳明交通大学陈俊勋前副校长来帮我们站在第2排上方，还有高正山主任、林松全副主任、魏远阳组长、苏瑞瑶董事长以及李义生处长，来我们的6位贵宾来，请帮我们好依序站在第2排的位置。好，但是很重要的是，大家都要露脸哦。好。OK 吗？来，我们是不是有请摄影师帮我们调整一下角度？我觉得大家可以再稍微的这样靠近一点点。来，尤其是我们第1排的贵宾。好，大家也站得太拘谨了。OK， 好，来，那我们是不是来为着我们这一次很难得的第1届这样的一个智慧制造机械设备安全管理的国际研讨会，我们一起来按个赞，看向镜头好吗 ？OK， 3、2、1。好，要再一张吗？那么换一个镜位，是不是？好，再一张。好，一样来帮我们这次的。 好，哎，请大家都要露脸哦，都有看得到镜头吗？哦，好，我们的穿着灰西装的贵宾来稍微帮我们往右边移动好了，哎，可以，OK， 好，来，我们再来一次哦，3、2、1，好，谢谢。好，我想真的，我们每一位贵宾，其实在不同的领域呢，都是扮演着很重要的角色，也是我们这个产业很重要发展的一块拼图。那当然，其实我们不同的一个角色跟力量的结合，当然让我们国内这个研发的能量，还有包括我们这次很注重的一个安全的规范，都可以不断的突破跟提升。好，那接着下来，我们就要准备进入到今天的正题了，就是要先来为大家带来第一场的专题演讲。Okay, now we'll proceed to the first keynote speech, and it's an honor to have Mr. Jack Gao, who is a Singapore expert and director of exida Asia Pacific, as our speaker today. And Mr. Gao is certified functional safety expert since 2013. Also has more than 15 years experience in functional safety, automation control system, and embedded software in different areas, including Industry 4.0, robotics and AGV, machinery safety, and process industry. 好，那么接着下来我们邀请到的这位讲者呢，他是新加坡的专家哈。那他接下来要跟我们大家分享的讲题就是 Industrial Automation and Control System (IACS), Cybersecurity in Smart Manufacturing, and an introduction to Australian IACS Cybersecurity lifecycle. 好，接着下来他应该已经在线上了。Okay.
Hello.
Hello, Mr. Jack Gao. Can you hear us? Okay, and now it's your time that you can take over.
Hey, good morning, everybody.
Morning.
It's a pity that I cannot see all you guys and in face, but it's my honor to give this presentation. To the webinar organized by PMC. And during my presentation, I will talk about the IACS cybersecurity in smart manufacturing. So in the first part, I will give a brief introduction about exida, who are we, and what do we do. And in the second part, I will talk about the IACS cybersecurity. We're covering what are the issues or incidents we have seen in the cybersecurity area and how the cybersecurity can be used and applied in the smart manufacturing. And what is the benefit of applying the IACS cybersecurity. So exida was founded in 1999, and we are specializing in functional safety. As the speech given by one of the honor guests, that if people are not pay attention to the functional safety, then it could cause the injury or death to the people. So we also focus and be the expert in the functional safety. And we also specialize in alarm management. So in this area, usually we focus on how to define a correct alarm to the operator. If there are too many alarms, then there is equal to no alarm. And another topic is the cybersecurity, which will be covered today. So exida provides mainly the three main areas to our customers. So we provide the lifecycle services. covering the beginning of the life cycle to do the risk assessment and to develop the either the safety integrity level or security level for the customer until the end of the life cycle, like the decommissioning of the safety function or the security function. And by doing that, we use our tools that is certified, and also we provide those tools to our customers so they can also enjoy the benefit of using the tools to reduce their development time and the cost. And also exida is an accredited certification body, so we issue the certificate to product, system, and also personnel. Other than that, exida is very generous to share the knowledge we have. So we have published many books. One of them is the book regarding the IEC 62443, which is the cybersecurity standard. So in this book, people can learn how to implement the cybersecurity standard in a pragmatic way. If you only read the standards, you may not understand what are the requirements clearly, but by reading the book, you will have a clearer idea. And other than that, we also publish a very good book regarding the functional safety for the standard IEC 61508, and also some other books in process functional safety, talking about the IEC 61511 standard, and together with some other databases which can be used by the end users. So exida is accredited to provide the following certifications based on different standards. So we provide the functional safety certification based on IEC 61508 and the IEC 61511. We also provide the certification for automotive industry based on ISO 26262. And we also provide the cybersecurity certification based on IEC 62443, also to the product, system, and also to the asset owner. And also the machinery safety certification according to IEC standard and also the ISO standard. And last but not least, we provide the trainings and the certification for the personnel. So both for functional safety and the cybersecurity. And this is one of the tools which is used mainly in the process functional safety. So this tool provides very good support and knowledge for the end users in process industry, how they can develop a process which will meet the requirement from the process functional safety standard. And these are the two tools that we are using in our daily work and also provide it to our customers. So I would like to highlight that this ArcX tool can be used for the cybersecurity threat modeling. So our customer can use this tool to do the threat model, which is a requirement by the IEC 62443 standard. So by talking about smart manufacturing, I believe the people who are listening to this webinar will know more than me. So in a smart manufacturing, everything will be connected, and not only connected internally in the factory, but could be connected to the enterprise network, or even to connect it to the outside network. And you may also have the machines to talk with each other, could include robots or AGV or AMRs. So in the factory environment, how can it be successful? We need to measure the availability to ensure the availability of the production and also reliability of the production and also the safety. So as a support factor, all these attributes will be affected by security. If you can imagine if somebody hacked into the factory, so it could affect the availability of the factory. It could also control, maybe change the machine configuration and indirectly affect the safety of the people. Therefore, the security is a very important factor. Yeah, so let's look at what are the incidents happened in the last 10 years or 20 years. So those accidents happened in different industries. Some of them happened in the water treatment industry or oil platform. And one of the most famous one is the Stuxnet virus, which infects the PLC configuration software. And therefore, in that case, the facilities are destroyed without the knowledge of the operator. So imagine this could also happen to any factory if we do not do well in the cybersecurity of the factory. And if you notice the trend, in the beginning of the 20th century, there are few incidents happened by the cybersecurity. However, in the recent years, there are more and more incidents happening. And some of them has caused a very tremendous cost to the end users. And I would also highlight several of them based on the related to the control system security issues. So some of them will affect the ICS and also the SCADA, which will be very popular in our factory environment to control our machines and the production lines. Yeah, so this is just one example of the cost by this NotPetya virus, and it costs as high as $10 billion. And that's why cybersecurity is very important to us. So, however, due to based on the statistics, about 54% the factory, the end users will experience the IACS attack. However, many systems are open to the threats, so they have the vulnerabilities. And few organizations are ready to respond. So this is a situation we need to pay attention to. And based on the incidents, about 80% are unintentional. So it could be caused by the unintentional actions by the employee. Maybe they open a phishing email, or maybe they use infected USB device on the machine. And 20% of them are intentional. So could be hackers or could be the insiders. So who will be the insiders? That could also be the employees, but unhappy employees. And if you noticed some news, some employees or contractors were fired, and because they have installed certain system for the end users or the asset owners, so they will do something bad to the owners by hacking into the system because they may know some secret password to the system. And based on the impact of the incidents, that's we have seen the number one impact will be the loss of production. So imagine if the factory is affected and cannot run anymore, so there will be a huge loss to the asset owner, and also the loss of the equipment control, and also could cause the injury or death of the people. That is also what we do not want to see. So the automation cybersecurity is to prevent the intentionally and also the unintentional attacks or impacts by the people that will be affect your manufacturing or IoT systems. And they could also be called SCADA security or PC process control network security, some other names. So this is this will be all these will be covered by the IACS cybersecurity. People may also think, since now I have already the IT people in my company, then I just ask the IT people to do the cybersecurity work for my production line. All right, but for the IT security, they have their priority. Usually, the confidentiality is their first priority. However, for the IACS security, the availability or safety or integrity could be our focus or interest. And the IT people do not know what is functional safety. So therefore, we need people who know the cybersecurity and also need to know the automation system in order to deal with the IACS cybersecurity. And we can look at, pick several of the priorities or differences between the IT and the OT security. So for, let's say for the availability, sometimes the occasionally outages is tolerated. However, for the OT, we do not want any interruption to my production. And also for the technology for IT is very fast to update the technology. It could be 3 to 5 years. However, for OT, the life cycle is very long. And also for the patching and the antivirus, it's quite difficult to apply it in OT environment, since before applying any patching or antivirus to my production line, I have to make sure there is no impact to the production. So we have to test the patching or antivirus in another system first before the mass application. So the cybersecurity is the responsibility of everybody played in this environment. So the product supplier should design and develop a secure product which has certain security features and do the thorough testing to those security features. And then the system integrator should use those products and also integrate in a way that is securely. And for the end user, even you have already implemented the secure system in the production line. But if the end user does not have a secure rules, this could also be compromised. For example, if the end user do not set a password, or maybe set a very simple password, like 123, then everybody can break the cybersecurity system. And therefore, in order to solve that problem, the IEC 62443 standard is developed. So at the beginning, at a very early age, nobody will think to hack an automation system. Everybody just to try to break the operating system like a Windows platform or Linux platform. Then recently, the cybersecurity becomes popular for automation system. And therefore, there are also some other organizations in the world to have similar requirements in cybersecurity, like the NERC or ISA 99 security community. So the IEC 62443 can be applied in Industry 4.0 and also can be applied for the robots. So I would like to highlight one interview by the ISA Secure to our Director of Cybersecurity in exida Salisbury, Mike Murdoff. So in this interview, Mike specifies the defense index for the should be used in the robot cybersecurity. So in the following slides, I would like to talk about what is covered in the 62443 standard for those who are not familiar with the standard. So there are 4 areas in the IEC 62443. So basically, first part is the general knowledge, and the second part is focusing on the policies and the procedures. Some of them are for the asset owners, some of them are for the system integrators, and the third part and the fourth part are for the systems and the component. So they define the security capability for the system and the security capability for the component. So let's look at in details. So how the 62443 can help to solve the problem we have in the manufacturing. So we may have the problem that insufficient security implemented by users. So in 2-4, 2-1 and 2-2 talks about some frameworks and some good practices to solve this problem. And for the insufficient security features in applications, we have the 3-2 to teach people how to do the risk assessment and to divide the manufacturing into the zones and the conduits. And for 3-3 and 4-2 to assess the capability, security capability of the system and the products, respectively. And for the vulnerability in software, the 4-1 defines a development process that the software should be followed. And also the 2-3 talks about the patch management, how to patch the software. And there are 3 levels of the, 3 security level types. So at first we need to define what is our target security level. Then secondly, we can determine what, based on the current system, what is the security capability of the current system. and to see whether it can be matched to the target security level. However, it does not mean that we just combine every system with the target security level, which can give us, by default, the target security level. We still need to do the security level verification to make sure what is the achieved security level. Yeah, so the benefit to adopt the IEC 62443 is for the end user, they just need to specify what is the required security level. And then the supplier can supply it. And also, it can help to reduce the time in the factory acceptance test and the site acceptance test. And for the supplier, it can be a product differentiator that if their process or product is certified, then that means they can follow the same process and can replicate the process, but and prove to the end user that they are capable to provide a secure product. And this diagram provides a very good example, illustration for the responsibilities of different players in the standard. So for the asset owner, basically it should follow the 2-1, which provides a framework how a asset owner should establish in the organization for the cybersecurity management system. And it can use the 2-4 to specify the requirements for the system. And for the system integrator, they can follow the 2-4 to do the integration or the maintenance of the system. And if required, they should be familiar with the 3-2, which will tell them how to do the risk assessment. And they can help the asset owner to perform the risk assessment on the factory. And for the system to be provided or used in the factory, it should be evaluated based on the 3-3 to make sure the system has the security capability. And since the system is comprised by different components or products, then for the product supplier, they should follow the 4-1 to develop those products. And the product could be applications, only software, or the embedded devices, including the hardware and software, or the network components could be the router, or the host devices could be a PC or SCADA system. And they should be evaluated according to 4-2 to make sure they meet the required security capability. So for the 2- structure, in the 2-1, basically the asset owner can establish a framework based on these requirements. And especially it talks about the configuration management. How can you identify each asset in the factory? And how can you make sure the data is secure, the user, whether you have used a strong password, whether the user needs to change the password regularly, and also the cryptography to encrypt the data. As in the smart manufacturing, the asset administration shell could be used, very popular, so that how can you make sure the AAS is to maintain the integrity and the confidentiality. And the 2-4 is mainly the requirement for the service provider. So although the products are secure, but you have to also make sure when they are integrated and maintained also in a secure manner. Therefore, the system integrator or system maintainer should follow this process. And regarding the system or the part 3 of the standard, in the 3-2, it mainly talk about how to do the risk assessment. And based on the high-level risk assessment, the factory can be divided into the zone, which are the grouping of the assets share the similar security requirements. And the conduits are the communication channels between each zone. In 3-3, it covers these requirements for the system. So for example, how do you identify and authenticate the users? And the users include human beings, also include the devices and the processes. So in a smart manufacturing, the devices should be able to talk to each other and get information for there to consume. So how can you make sure the authenticated device gets the information which is authorized to them? And in the 3-3, we will also evaluate how to ensure the integrity of the data at rest, the data at transit, and also the confidentiality of the data, and also the timely response, whether you have a detection system to respond to the incident, and also whether there is a degradation solution if something happens, like the denial of service happens. What will be the degradation of the system? There are 4 security levels, and the higher of the security level means the more requirements for the system. So security level 1 basically means individual unintentionally compromise a system. Then for security level 1 is to protect individual intentionally to break a system. Then for security level 3, basically to protect it from a group of people. Then for security level 4, usually it is the protection from the government hacking activity. And from this table, from the part 3-3, we can also see for higher security level, there are more requirements needed for the system. So for the part 4, basically, this is for the product supplier or the OEM to follow. So in 62443, 4-1 and 2-4, it defines 4 maturity levels. So for maturity level 1 is like you have the procedure to follow, but it's not documented. Then for maturity level 2 means you have the documented procedures. You have the people trained, and you are ready to follow it, but it has not been followed at least once yet. So it means the product or system is not designed or developed by following the procedures yet. Then for maturity level 3, it means based on maturity level 2, the process has been followed at least once. And for maturity level 4, means you have a process to improve this process based on the monitoring and the feedback process. So in the 4-1, it defines 8 practices that a product supplier should follow in the product development lifecycle. So basically, the security requirement should be managed, and based on the management plan, the security requirements will be specified and designed in a secure way to do the threat modeling, to check what are the vulnerabilities in the products, and also to implement securely. For example, whether there is a coding standard to be followed in the software. And after that, we need to verify and validate the security features by testing. It could be the fast testing or penetration testing, and also to manage the related issues, and also how to manage the update, how to inform the customers affected, how to issue the patch, and also what are the requirements in the security guideline, which will document what to be paid attention to when using the devices in the system. Then for 4-2, it's similar to 3-3. It's derived from the system level, but applied to the device level. And there are 4 different types of devices. Embedded device, like the RTU or PLC, the host device, like a PC running the Windows OS, a network device such as routers, application which is software only. So now let's look at how we can apply the IEC 62443 life cycle in a project. And this is not only applicable in Australia, but can be applied in any other countries and other projects. So the whole life cycle can be divided into 3 phases. Assess phase, mainly we do the analysis and the determination of the security requirements and the security level. And after that is confirmed, we can implement it until the system is installed and validated. However, the work is not completed yet without a correct maintenance phase. So during the maintenance phase, we need to look at how to do the patching, the antivirus management, and how to do the monitoring and modification, and also the periodic security vulnerability assessment. So let's look at them in some details. So first, we need to define the scope of the system. And we will do a high-level risk assessment. So the high-level risk assessment will help us to find out what are the areas we should pay more attention to in the later stage when we do the detailed risk assessment. So this can help us to save some efforts and costs. So we need to look at the worst case scenario, meaning do not put any countermeasure when we do the risk assessment, and assume this compromise will happen, this threat will always happen, and then group the factory into different zones and conduits, and also need to document the incident response plan. So as we know, we may have an initial risk in the factory. So the objective of the risk assessment is to reduce the risk to the tolerable level. So we need to reduce the risk below this tolerable risk. However, we know the risk cannot be totally removed. So there will be a residual risk. So the risk will be reduced by other security measures. For example, the physical security, you may put some lock or put a security guide to some critical assets. And also the personnel security, you may train the people. And also the network segmentation, you may separate the critical control system from the non-critical control system, and also from the enterprise network. And after all those measures are considered, if we still need to reduce the risk further, we can implement the countermeasures. One example for the zones and the conduits, based on the high-level risk assessment, we can group our assets into different zones. So for example, we can have the enterprise zone, and for each factory, we can have factory A zone, factory B zone, and even within the factory, we may have control zones. We can separate them based on the criticality of the control zones by using routers or firewalls. So after we have decided the zones and the conduits, we can do the detailed risk assessment. So in the detailed risk assessment, we will look at the risks that are most interested to us. So we can document, analyze the threat and their likelihood, and create the possible consequence, to determine the possible consequence, and to create the countermeasures to the consequence, and to check whether the countermeasures can help us to reduce the risk to our tolerable level. So one of the activities is the vulnerability analysis. So during the risk assessment, we can review the existing practice and the policies, and review the network architecture, and also review those measures for critical employees reporting findings, and to compare it with the industry best practice. So there are several websites to list down the best practice, also list down the vulnerabilities that can be referred to. And we can recommend the possible solutions to the gaps. So to identify the countermeasures, we will use the defense in depth strategy. So that means we may have many countermeasures. So in order, rather than using one countermeasure, we try to combine different countermeasures. And these countermeasures will be will not affect each other, means interference, independent countermeasures. So we will assume other countermeasures will be compromised. and only this countermeasure can work. Then in this way, in order for the threat agent or the hacker or the unhappy employee to attack our control system, they have to break each of the defense. So for example, we may have the virus scanner, and we may have the access control to properly define who can access the authorized property. And we may also use the DMZ or the firewalls to increase the difficulty for them to get into our control system. So in this way, we can use the countermeasure to reduce the likelihood and reduce the consequence. And these are the two factors to determine the risk. So after the countermeasures are determined, we will create the cybersecurity requirements specification. So this document will specify what are the security measures to be implemented and what will be the security level target for the zone and the conduit. And it can be a separate document. It could also be combined to the existing either the safety requirements or the existing requirements specification in the organization. So in this document, the management of change should also be documented. So next, when we implement the security countermeasures, we can choose different architectures. So let's have a look at several examples of the architectures. So in the left-hand side, in this example, every device is connected together, and there is no separation or segmentation between them. But in the middle, we could add certain router or layer 3 switch. Then at the right-hand side, we could add the firewall. So different architecture also can give you different protections. We can see from the left-hand to right-hand side, the protection is increased since we segment the device, and also we use a better device to provide the protection. Then it comes to the validation of the security level. So we need to make sure after putting all the devices together, the security level achieved can meet our security level target. So we can use the prescriptive method, like those requirements mentioned in the 3-3 for the system, or the 4-2 for the component, or we can use a qualitative, use a semi-quantitative method. Basically, in the semi-quantitative method, we can assign the score to the risk and also to the countermeasure. And this can be done by using the Cyber PHAX tool provided by exida. So the outcome of the security level verification is to verify whether the security achieved in the IACS, and also to ensure that the design meets the cybersecurity risk and maintain the cybersecurity of the system in the operation and the maintenance phase. So once the security level is verified, here comes to the construction, the installation, and the site verification. So we will design the system based on the requirements, and also need to create the inspection and the test plan. So one of them is the cybersecurity factory acceptance test. Usually this will be done before the system is shipped out of the factory to the asset owner. So the system integrator should create this plan and test the system, try to, in as close as the environment as close as to the real situation. And this is a good chance, good time to do the penetration test. And also, once the system is shipped or installed at the site, before the system is running, the site acceptance test can be done. And this is also a good opportunity to do the pen test. But we have to remember that the pen test will interrupt the running of the system. So just to make sure it should not be done once the system is running and online. And then finally, it's installed and commissioned. And initial validation should be done after the system is installed, and some metrics can be collected to review whether the countermeasures are in the way what we expect. So in the maintenance phase, we have to care about the patch management. Once there is a patch or a new antivirus update, we need to make sure before we apply them to the mass system, we should make sure it will not affect the production, and maybe apply it in a single system first before applying them to the mass systems. So the above security life cycle can be well followed by the asset owner and the system integrator. Then how about the product supplier who provide those security products? So in the product development, usually this is the life cycle or development process used in the IEC 62443-4-1. And all these requirements can be applied at different range. Like we can imply the security requirements during the requirements analysis phase, and use the threat modeling in the security risk assessment and architecture design phase, and create the security coding guideline for the software developer to follow, and also perform the security code review and the analysis, and also the verification and the validation testing. So usually when we certify a product according to 4-1 and 4-2, we will do the following 3 steps. And the security level will be determined by the minimum set of the features. So first, we need to audit the development process to make sure the OEM has established this development process based on according to the 4-1, and they need to follow it. And also, we need to perform the testing, like the robust testing, to make sure the system, the product still can perform the functions during those fast testing and the storm testing. And also the product needs to perform the functions they have claimed, and also to scan the vulnerability scan, the vulnerabilities in the product based on the latest database from the tools and the website, and also to do the binary scan. There are also tools to analyze the vulnerability in the binary image of the software, and also to perform the pen test to the device. And after the development process has been audited, we need to audit the security features based on the 4-2 to make sure the device can achieve the capability of the security level. So we can certify the process, certify the device, system, and the personnel, as mentioned before. So let's look at what exida provide on the certification. So we can certify the process according to 4-1 for the device supplier, and we can also certify the process according to the 2-4 for the system integrator, and we can also certify the device developed according to the 4-1 and the 4-2, and we can also certify the system developed by following the 2-4 and the 3-3. So the following slides just give a visual presentation for which standards should be, which part of the 62443 should be followed. Like for this process certification, 2-4 and the 4-1. And for the device, 4-1 and the 4-2. For the system, if the system is developed by the OEM, then it can be certified by following the 4-1 and the 3-3. If the system is just integrated by the integrator, then it can be certified by following 2-4 and the 3-3. And this just gives several examples of the devices we have certified according to the 62443. And at this time, so far, exida has certified the most cybersecurity devices in the world, and it's more than 50 in terms of numbers. So more information can be found on exida website, the security automation equipment list. So for the personnel, we have the CACE, the Certified Automation Cybersecurity Expert certification. And we also provide the training, and more information can be found also on the website. And that is all from my presentation, and I hope you enjoyed it and you can get some useful information from the presentation. And if you have any question, yeah, please feel free to contact us. Okay, thank you very much.
Okay, thank you very much, Mr. Jack Gao, for your time and your valuable input for us. And thank you very much. And now we have the second speaker, who is a technical director from UK, Mr. Peter McNicol, who has 25 years experience in this industry and having trained as a mathematician and software engineer. And Peter is also a member of Institute of Engineering Technology, the British Computer Society, and is a chartered IT practitioner. OK, 好，那接着下来我们要邀请的这位讲者是来自英国的专家，一个技术的总监。And now, Mr. Peter is going to bring us the topic about the safety development trend of smart manufacturing in Europe and the development of safety management after Brexit. 好，他接下来要跟我们大家分享的这个讲题呢，就是在欧洲智能制造的安全发展趋势，以及在英国脱欧之后这个安全管理的一个发展。那接下来我们就邀请他来分享这个讲题。然后上个洗手间，那5分钟之后呢，我们就回来，再进入到我们下一场的演讲。 好，我们可以开始了。
Hello, my name is Peter McNicol. I work for two certification bodies. One is Safenet Limited in the UK, which can offer UKCA marking for machinery and EMC and LVD. And one is Safenet Certification Services, which is based in the Republic of Ireland, which can offer CE marking for machinery, EMC, LVD. I've been asked today to do some seminars for PMC covering what's happening with Brexit and also ISO 1161, its current status and its interaction with smart manufacturing. A little bit more about myself. I used to work for a company which designed and manufactured safety components before I started working for a notified body. During the past 20 years for standardization, I've been involved in multiple different standards, ranging from basic safety standards on safety distances to complex presses and other more expansive machinery. So we'll move forward to doing the presentations shortly. Hello, this presentation is about Brexit, how we got here, what's happened in the process and where we are now and what could happen in the future. So if we start, so the process started by the UK people wanting to exit from the European Union. There was quite a large number of people wanted a referendum. So the UK held a referendum in 2016. And then there was a lot of negotiation, then there's a transition, then there was a UK EU trade deal, and now the current situation is a little more complicated. So if we go through this step by step, and hopefully it'll make more sense. So at the beginning, we had before the referendum, there's a lot of campaigning for leaving. And there was very limited campaigning for remaining within the EU, within the UK. This led to an awful lot of misinformation, untruths, and lies and propaganda propagated by the Leave campaigners. A lot of it was about money that was being spent in the EU and what the EU makes us do, which they didn't want us to do. And it wasn't necessarily, most of it was incorrect, or if it was correct, it was only partially the truth and it wasn't the full truth. So on the 23rd of June, the UK voted to leave the EU. This was only the start of the process. The length of time on the process was unlimited. It could have gone on for a long period of time. But from that day, the first Prime Minister to resigned due to Brexit. So David Cameron resigned, and that then added extra delays to the process and negotiations because they couldn't then start the next stage until we had a new Prime Minister and they had a remit to operate. So at the beginning of Brexit negotiations, the majority of the Brexit deal, this was the deal which would need to be struck for leaving. So this is about how much money we owed the EU and how much money the EU were going to pay us and who was going to do what and how it was going to operate. And this is what some people called the divorce agreement, but it was the beginning of it. There's three main sticking points. And that was Northern Ireland, the level playing field, and state sponsorship of companies. So the Northern Ireland problem relates to the issues about Northern Ireland going back a long period of time. There was an awful lot of unrest in Northern Ireland, and there was civil riots and killings relating to Ireland and Northern Ireland being one country and not being not being a country. This was resolved by what was called the Good Friday Agreement, which was partly brokered by the US. And this said that the border between Northern Ireland and the Republic of Ireland shouldn't have any border controls, and it should be open. This was mainly allowed due to us being in the EU, but now this caused sticking points for trade, conformity assessment, and other things. So this caused a major problem. The second problem was the level playing field, and this was the EU didn't want the UK to give unfair advantages to UK companies and making it hard for EU companies trading in the UK, and the UK had similar issues with the EU. State sponsorship was another very large item that the EU were concerned that the UK government would give state money to some companies to give them a better economic advantage against other EU companies in the same marketplace. All of these created a very complicated deal, which was rejected a number of times by the UK Parliament, and resulted in our second Prime Minister, Theresa May, resigning. This led to Boris Johnson becoming Prime Minister. During the first period of time, he forced through a very poor Brexit deal, which wasn't thought through correctly. So especially Northern Ireland was not considered sufficiently within his new deal, within his new deal that he had for Brexit. So what the divorce or Brexit deal meant was there was a 1-year transition. That could have been extended by 1 or 2 years, but that was rejected by the UK government. So that meant that on the 31st of January 2020, the UK left the EU, but they would go into this transition period, which would continue to follow the EU laws and until the 1st of January 2021, and then we would cease to follow the rules, and the EU and the UK would be officially separated politically, economically. Once we entered the transition period, that's when the UK-EU trade deal negotiations began. This, due to the limited time and the UK government rejecting any extension to the transition period, meant that we ended up with a very basic deal. The deal is effectively barely covers tariffs. There's no conformity assessment agreements. There's no acceptance on each other's laws and standards. So it's very, very basic, and it's not very helpful. And the Northern Ireland situation is very, very difficult because that basically Northern Ireland has remained within even though it's part of the United Kingdom, it's remained within the customs union, whereas the rest of the United Kingdom isn't. But there's very special rules for selling products into Northern Ireland. So everyone needs to be aware that if they ever sell products in Northern Ireland, ask what they need to do, because it's not so straightforward. So the current situation with Brexit is that from the 1st of January 2021, Europe ceased to accept UK notified bodies certificates. This has caused significant upset because the UK said they would continue to accept CE marking and European notified body certificates initially for 1 year, and now it's for 2 years that they're accepting the European certificates within the UK. The UK has also introduced a conformity assessment system, which has a UKCA mark. Currently, this is all based on the EU legislation that was in place on us exiting, but it will slowly get modified. all the product directives which were transposed into UK law as statutory instruments have been modified by a piece of UK legislation called the Product Safety and Metrology, etc. Amendment, etc. UK Exit Regulations 2019, which just rolls off the tongue, and I call it the Brexit Act for ease. This has very little changes to what actually happens. So the majority of the legislation has remained the same. There's lots of changes EU to UK, or deleted any reference at all. Notified bodies can change to approved bodies, which they're the same bodies. They've just changed the title, and everyone's had a new appointment letter. There's on a different website, but everything's the same. Harmonised standards have changed to designated standards for the UK. The original list of designated standards has just copied the EU list. This has now started to be modified for some directives. It's taking a little bit longer for the UK designated standard to be designated compared to the EU version, compared to the EU, as we have put in place an additional checking process for the UK. So once the EU checks are carried out while the EN is in development. So the EN is then published, then the UK will do their checks of the standard for the UK designation. So what this means for you and Brexit is that if you have to have any mandatory examinations, they would need to be redone or dual certified for both Europe and the UK market. You need to apply UK CA marks to your products. So this is on the rating plates or elsewhere on the product, but it needs to be clear who is responsible for the UK CA mark. You need to issue a declaration of conformity for UK CA marking. Now this has slight differences to the EU declaration of conformity or the EC declaration of conformity, but it's easy enough. It's just another piece of paper. And as organizations, you need to track the UK designated standards and the EN standards. This because they may not be the same and they may deviate. So the UK may designate some standards that the Europe doesn't, and vice versa. So you just need to be careful there. So that brings us to the end of the Brexit seminar. If you have any questions that you have, if you pass them through to PMC, I'm sure they can pass them to me for answering. So thank you everyone for listening. Now if we look at the ISO 11161 standard and what's happening with it and smart manufacturing. So let's begin. So ISO 11161 is currently on its second edition, which was published in 2007. There is an amendment to that which was made in 2010, but that was just updating some standards references and some errors in the original standard. They have since then started a new work item to update the standard to include modern technology and the way that the manufacturing is moving on, like smart manufacturing, etc. The current document is at committee draft. So this is the first time that the international community, standards community and experts have had a chance to see the document and see how this update is going and how they wish it to move forward in the future. So as an expert, I'll put some comments in about the document, and hopefully they will take those comments on board and modify the standard accordingly. There should be another 2 stages. on this document. So the next stage would be inquiry, where then we get to vote, say, yes, it's good, and this is our comments, and that you can put in technical comments and vote, it's okay. And then there's a final vote where they've taken all the technical comments, put them all together, and come up with the current consensus of what the standard should be for this area. This seminar will cover the major changes that have happened in the standard and which are in this committee draft, and try to explain how they then have an impact on smart manufacturing. So, the main changes to the standard are, they've changed the title. I know that it seems like that's not important, but it's quite important that they've changed it from you're making a combining things to make a machine, and you're combining two machines into a larger system. And the system be a complicated system or a less complex system. But that's it's quite a distinct change in their view and the scope of the standard. Other areas that have changed is that the risk assessment has had additional requirements added. The additional requirements are the limits of the machine or system, includes connected networks, which we'll discuss later. It's got layout analysis. It's got multiple configurations now that includes in the risk assessment. Other areas are risk reduction, which now aligns with 12100. Again, we'll discuss that a little later. Safeguarding area has been updated, so spans of control has been expanded and explained better, so it should be easy to understand. They've introduced a level of functional safety under the span of control and safeguarding, so it makes everything a little bit clearer for the integrator of machinery. Other areas which have been, these are new things which have been added, so we have automatic selection detection fields, which is quite important when you have production lines or systems where they produce multiple products, multiple size things. They have different interactions from the user, etc. And then you've got special modes. Again, this is all about human system interaction. And then we've got initiation warnings. This is a new annex. So these are 3 new annexes which have been added to the standard to try and assist the integrator or system builder into having adequate risk reduction. All these 3 annexes are about reducing the risk for the machine. So the risk assessment changes. The standard has been restructured to make it more usable and readable. So now it seems that the risk assessment area seems to flow better and is more understandable to use. It makes a large difference for lots of people that they're not flicking backwards and forwards looking for, oh, it says this, oh, that's 20 pages forward. So that's not there anymore. So that hopefully that restructuring will make an awful lot better. It's clearer that there are now multiple configurations allowed. So this is important for smart manufacturing to allow automatic changes of the configuration or even manual configuration changes. And the risk assessment has to deal with that, but it makes it clear that you need to do that and consider all the possible configurations of the machines. So if you have a bypass on one of the processes because it's only used when you're doing one particular product, or even the same product but for different customer, then it's important that you consider those other configurations and the safety and the risk reductions are achieved, and you don't have additional hazards and risks added because of the configurations. Now, the limits of the system has had further guidance and requirements added. There's now 17 items listed for the limits of the machine. which is quite a lot. The main four items that have been added is time limits, interface limits, human factors, accessibility to safety functions moved by connectivity. So the time limits are relating to the production rate, cycle times, life cycle, the maintenance, wear and tear on components. So these are the time limits that you'd include in your risk assessment. So if you have a main component, which is a main mechanical component, which if it fails can cause an injury, then you need to consider lots of maintenance on that component and maybe a replacement after a certain time limit. So you also have other things like the production rate, how quickly things are moving. This has impact on the risk assessment and how you deal with certain things. Cycle times, that's very similar to production rate, but it's especially if somebody has to interact with your system. So if that's regularly or not, it all needs to be considered. The interface limits. Now, this is where the end of your system is, or in some places, be the end of your control zone would be. We'll come to control zones in a minute. So the limit, and you need to consider that the energy sources as well. So the energy source not all energy sources will necessarily cease when you stop your system. So there could be, could have workpieces which have inertia or packages which have inertia, and they will still be moving and could cause possible hazards onto a follow-on piece of equipment or the interface to another piece of equipment. Other issues, so other areas of energy which you need to possibly consider is gravity fall. So if something slides down a slope into another machine, or it's just all those circumstances need to be considered, and that's where you define the limits of your interface and you assess the interface as well. Human factors is interesting for a lot of reasons because it's been around for risk assessment for a while, but it's only in the last maybe 5 to 10 years that people have been taking it very seriously. So this is to do with ergonomics. Well, it's ergonomics, cognitive processes, and time requirements that you put on people. So when you consider ergonomics, that's how easy it is for people to interact with the system. Not such a big idea for, not necessarily such a big thing for smart manufacturing, but you need to consider what people are doing. What's more considered for smart manufacturing is cognitive problems. So this is where you have an operator watching a machine which doesn't do anything, or it just does everything automatically, but you need somebody there just to make sure it's running okay. They then lose concentration and could miss dangerous hazards and dangerous situations where they should have done something. So it's things that need to be considered for smart manufacturing specifically. And then you have time requirements. So if you have something that somebody has to do very quickly in a very short period of time, that increases the risk of injury because they're then rushing, and what happens if they don't complete it in time? What's the consequences of not completing in time, especially on their work and so forth. Right, and then we come to the big one, and this is a very important one for smart manufacturing. This is where you have accessibility to a safety function by connectivity from something else. So this could be however you wish to do it. In theory, it could be by networking, it could be by Wi-Fi, Bluetooth, any of these ideas that you have access, something else has access to your safety function. To adjust it, so you can allow configuration, maybe automatic configuration from a central processing, a central unit, which isn't part of your system. All of these things which you then need to assess. And you may need to consider things like additional risk assessments for cybersecurity, the possibility of malicious access. What's the possibility that somebody wants to maliciously damage your product? And then there's accidental access, which is probably more likely that somebody accidentally connects to your machine and does something. But they need to be considered. So further on into the risk assessment is work tasks and task zones have been expanded. They've got a larger entry in the standard. This is to try and help you understand. So a work task is the task when somebody does something. So you say this person goes and presses that, does something on the machine, and that's a work task. So it's a human machine or human system interaction, and that's the work task. The task zone is an area within your system or machine where work tasks take place. So you can have one zone and it could have multiple work tasks going on, and the task zone could have multiple hazards within that zone. So this is helping you define what you do and where you do it. And where you do it can be for more than one thing, but what you do is probably only one thing. Okay. So when we come to risk reduction, the risk reduction has now been aligned to 12100. Previously, it wasn't aligned. It was missing out one of the hierarchy elements of 12100. So there's three hierarchies in 12100, and this is most risk assessment methodologies, where you have a hazard, you design the hazard out, or you safeguard it, or you give information and guidance and labeling and marking. So now, the previous ISO 11161 did not have inherently safe design. So inherently safe design is the equivalent step of design the hazard out. So this is, so you remove the hazard from your system. So then you don't need to safeguard it, you don't need to consider it any further. This now has its own clause within ISO 11161 because it's actually it's fundamentally the best method of best method of risk reduction that you can do. Not to consider it would be wrong. Many people don't consider it because they know from experience that it's not normally possible. So then if we come on to safeguarding, and safeguarding has been expanded dramatically. In the original standard, safeguarding was pretty much the majority of the document. The original ISO 11161 was how to safeguard multiple machines. There was an awful lot of safety component manufacturers involved in production of that document. Very few machine builders were involved. So you can understand that the emphasis was more on safeguarding and how to put our products on your machines. So what we have is they've expanded. Now you have control zones. So if I explain what a control zone is, a control zone is an area of your system where you limit that you think needs to be controlled. So an ideal example would be that you've got a system and you have a robot cell in your system. So your robot cell would be one of your control zones. So you're trying to control, you can be controlling that area with safeguards, like interlock doors, maybe some light curtains, but you've got this zone which you want to control, and you will probably always want, if anything goes wrong in that zone, you want to stop that area totally. Then you come to span of control, which is slightly different. So the span of control is what does one thing do and how far does it expand? So a good example would be on your system you have an e-stop, and that e-stop stops everything in your system. So its span of control is the whole system. But the interlock door next door to it, if you open that, you maybe only want to stop that one control zone that you enter into. Or maybe you walk through one light curtain, if you interrupt a light curtain, you may want to stop two control zones, but not the third control zone. So that would be the span of control for your function. So these spans of control should be considered within your risk assessment as part of to determine what they really should be. There's other spans of control within your system. There's functional spans of control, which would be you define during your normal functioning. So that's just how the other systems work. But mainly for safety, you do that. So this then comes forward that you have functional span. So then they brought in. So for smart manufacturing, obviously, this is going to be quite important, that you have lots of different areas, lots of different safety components, lots of different safety functions, stopping, lots of different things. So that then falls into they've then added a table for an examples for functional safety for span of control. And that looks like this. So you now have, so if we look at, so effectively it's saying that you've got interlock devices or the light curtain or emergency stop, and it says the locate. So if you look at the table, it says what location. So you have, say, look at the access door number 3 on the interlock device, access door number 3. So you look across there and you've got the balancing machine and robot number 2 and the packaging machine are part of its span of control. So that if you open that door, it stops the balancing machine, robot number 2 and the packaging machine. Now that's fairly straightforward, but for each of those different machines, the PLR will be different because the amount of risk reduction required for each of those machines is different. So for the balancing machine, we have PLR of D, robot number 2 was PLR of D, and the packaging machine was C. So what you do is you take the worst case, which would then be D, would then be your span of control for the PLR for the span of control for that access door number 3 would be D. If you don't, so it'd be very easy to end up with a C, because if you don't properly document and be sure what you're doing. So then we come to the special, so one of the special annexes, which is automatic selection and detection field. Now this is really, this isn't new, but it's the first time in this document. So if you have a system where you have different things passing through detection zones, so so you may wish to adjust the detection zone of a detection field of a safety component to allow parts to move through, maybe, or that you don't need as much room because things are slowed down. All these things. So you adjust the detection zone. So if you have an outfeed which products come out of a machine or system, maybe you're producing small parts, so therefore you don't need the top half of your, you only need to stop, you only need to stop detection in the bottom part of your light curtain, and the top part of your light curtain can remain active to stop people accessing your danger areas. Or even more complicated methods are laser scanners, where you can switch the detection fields and the detection zones to be different shapes to allow hot products to pass through, maybe even the vehicles to pass through the detection zone, all to just aid the automation of the system, so the manufacturing system doesn't stop, but other things can happen. As I said, for many safety components, this isn't new, but this is the first time in this document, and it's actually the first time it's been defined properly without being on for a specific type of machine. So then we can move on to the two new annexes, which they're not particularly large or complicated, but they're fairly important for smart manufacturing in some situations. So we have the two are special modes is one, and the initiation warning systems. So when you have so if we start off with the special modes, special modes have been around in product-specific machine standards like lathes, machining centers, for a fairly long time. So these are modes of the machine which allows special people to interact with the machine to do setup or to do other types of interactions with the machine. They're not meant to be normal operation of the machine. So that's why they're a special mode. So you have, so if you have a smart manufacturing system and something needs to happen, so say something needs to be changed or something needs to be loaded in, you may wish to, instead of stopping the machine, may wish to slow down that particular area of the machine while a trained operator can go in, do what they need to do. Everything's going slower, so the risks are much reduced, and then they can come out and the machine can then continue at full speed. Those things are considered in this annex. The initiated warning systems are are important for a different reason. Because many of these systems are centrally controlled, so many of these large systems are centrally controlled, it is fairly easy, it's fairly possible and foreseeable that somebody could be in an area which they could be in danger if the machine runs. So in those areas, it's not always possible to guard. It's just not, it just doesn't, some systems just don't work that way. So what you can have is you can have a warning system which gives them a warning that something's going to happen. So this can be a loud noise, it can be flashing lights, it can be lots of other methods of warning people that hazardous motion is about to begin. And this annex gives ideas and methods and timings for these systems. So that covers about all of the issues and modifications to ISO 1161. I tried not to go into too much detail, otherwise it would be a day's seminar instead of just a short, quick seminar to bring you up to date. Thank you for your time. If you have any questions, if you pass them to PMC, I'm sure they'll be able to either answer them or pass them on to me, and I should be able to send some responses. Thank you again for your time. Goodbye.
好，那么在这段影片，其实我们也非常感谢来自英国的技术总监 Peter 给我们带来的一些分享。那so our first section of forum has come to the end, and it's our lunchtime now. And our second part of forum will begin at 1 p.m. So please be back earlier so that we can start on time. 好，那接下来呢，就是我们提早让大家进入到这个中场休息，然后午餐的时间。另外，我们很贴心的帮各位把这个午餐都放进来哦，就在我们这个会场的后方，所以各位贵宾，我们待会儿就是可以自行。 好，各位贵宾，那么我们现在时间是12:58，所以也是差不多，我们要进入下半场的研讨会。好，如果外头有其他的贵宾，他们可能还没有回来的话，好 ，OK， 那我们待会儿就是1点钟会准时开始。好，各位贵宾，大家午安 ，Ladies and gentlemen, welcome back to 2021 Smart Manufacturing International Forum. And now we'll proceed to the third keynote speech that we have Mr. Jason Smith, who is a principal engineer at UL. And he has focused on standards development, internal and external training, and certification for safety-related control systems and robots in consumer technology. 那他今天为我们带的这个讲题哦，就是 as you can see, the development trend of UL 3300. 那我们接着下来呢，就直接来进入正题。那我们一起来看一下他的这段的演讲。
Hello, I'm Jason Smith, Principal Engineer of Robots and Control Systems at the safety science company UL, Underwriters Laboratories, and I'm here to talk to you today about the development of a new consumer robot safety standard, UL 3300. I'll say a few words about me. With UL, I have 16 years of experience in safety certifications and standards development. I initially focused on safety-related software and functional safety, and then expanded that to include specific end products such as robotics. During my time at UL, I've been an active participant in quite a few different standards technical panels and technical committees, such as STP 4600 for autonomous systems and ISO TC 299 for robotics. During this presentation, we'll focus on 3 topics related to UL 3300. First, I'll give some background on robots in the consumer space and how it led to the creation and development of UL 3300. Then, I'll talk to you about the first step in the development in the standard, the outline of investigation, and then provide you with a summary of its requirements. Finally, I'll talk about the steps that we'll be taking to develop and publish the consensus standard UL 3300 through UL's standards technical panel. Let's first talk a little about the history of robotics in the consumer space and how it led to UL deciding to develop a new standard for consumer robots. The concept of robotics has been around for hundreds of years, but its first real-life example was in the 1950s in the industrial space in the shape of a robotic arm. As electronics became smaller and more powerful throughout the second half of the 20th century, the use of robots became more widespread, particularly in industrial factories. Typically, this was in a controlled environment where the robot was bolted to the ground or on a fixed track and programmed to perform simple, repetitive tasks. Because of their increased use and associated mechanical and electrical risks, UL went on to publish a new standard, UL 1740, in the year 1995 to help address those risks and make sure that those robots were safe. Currently, UL 1740 is on its 4th edition. Automated guided vehicles were invented around the same time as the first robotic arm, but their use only became more commonplace as technologies and advancements in electronics, sensors, and the like took place over the last few decades. These automated guided vehicles, or AGVs, and mobile platforms had the advantage of not being bolted on the ground or constrained to a track. They used things like magnetic tape, active electronics, and maps to navigate. Similar to the first robots, these AGVs and mobile platforms operated in a controlled environment, but in closer proximity to humans. Therefore, UL once again published a new outline of investigation, UL 3100, in 2018, which has recently become its own consensus standard. While robots had been depicted much earlier in the consumer environment, in television shows and cartoons, they first started actually showing up in places like the home only a couple of decades ago, whether it be Sony's Aibo or iRobot's Roomba robotic vacuum cleaner. But now it's becoming more and more commonplace to see these kinds of robots in these places. Some examples of this. So, the local supermarket. The local supermarket that's 5 minutes from my house has this particular robot model rolling down the aisles to scan inventory and things like that. You may see these kinds of robots at your nearest commercial airport. For example, I've seen this one when I've flown out of Korea's Incheon International Airport. As mentioned previously, you might see these robots right in your home. Similar to Sony's Aibo, companion robots are becoming more and more commonplace to see in the home. And you might see these kinds of robots in your office or place of work. So the increase in use of consumer robots is obviously very interesting news for everyone. However, the increase in the use of these robots also potentially brings with it safety concerns. With respect to consumer robots, advancements in technology have enabled functions that were previously not possible to now be possible, and for them to be less expensive as well. There are now fewer, if really any, limitations to what can be done. And it also is going to enable these robots to be mass-produced. Though, with these robots now operating in these new environments like the home and the office and an airport, possibly in a restaurant, they're going to be around people who may not be really familiar with the robot. So therefore, there are some additional challenges for those who design these robots to ensure that they do not pose danger to people, the environment, or to themselves. As mentioned previously, UL had created standards for industrial robots, AGVs, and mobile platforms to address risks associated with those kinds of robots. The question then becomes, should UL create a standard to address risks associated with consumer robots? If we look into some research that has been done, it is clear that use of robots for various applications are projected to continue growing at a rapid pace, well into the double-digit percentages in the next 4 to 6 years, particularly for use in retail, delivery, and leisure applications. So consumer robots are certainly not going to go away anytime soon. And if you look at consumer confidence in robots and artificial intelligence in general, while there are many folks that have a positive outlook, either fairly positive or very positive, there are also still many, many people that are skeptical of their use. Maybe as many as 30% or 40% of folks that have some concerns with robots and artificial intelligence. So, as a result, a couple of years ago, you all decided that a new safety standard, UL 3300, was needed to address the safety of consumer robots. UL has taken a two-step approach to creating this new safety standard. So first, we published an outline of investigation last year. And in parallel, we are forming what is called a standards technical panel to create a consensus standard. So I'll provide some further details on each of these, the outline of investigation and the consensus standard, in the next two sections of this presentation. Let's first take a closer look at the outline of investigation that UL published last year and what exactly that is. UL issued the outline of investigation for UL 3300 in August of 2020 with a title of Service, Communication, Information, Education, and Entertainment, or SKY, Robots. So an outline of investigation is a published document that contains initial requirements that can be used to issue a certification mark. So these initial requirements were written by UL without any sort of formal collaboration with any other organizations, and at this point is not considered to be a full-on safety standard. Not yet, anyway. So it's generally understood that an outline of an investigation may have requirements that are still in development or that have otherwise not been finalized, and that these requirements would be further discussed in a standards technical panel at a later date. So we'll talk more about the standards technical panel process a little bit later. But for now, let's talk more about what's in this outline of investigation. So what kinds of robots are in the scope of the outline of investigation of UL 3300? So first of all, we have service robots. So they provide assistance to humans, and they tend to perform jobs that were once done by humans. We look at the robot on the left here. It's acting as a server in a restaurant. You'll see that it includes an interface in which a human could order a beverage, and then the robot could retrieve and serve that beverage to the human. Next, we have communication robots. They offer the ability to use telepresence to allow humans to meet remotely instead of having to meet face-to-face. Next, we have information robots. They provide guidance, directions, and things like that to humans in large and potentially unfamiliar locations where people could get lost. Those places could include things like airports and shopping malls and things like that. Education robots, so they're used in places such as schools. They could also be used in places such as in the home, libraries, things like that, to help facilitate teaching and instruction to children or possibly even adults. And then we also have entertainment robots. So entertainment robots generally are going to be providing some sort of amusement to humans. For example, the robot on the right here that's playing the trumpet. So what is the general approach that we've taken in this outline of investigation for UL 3300? Well, because many of the components and subsystems that are going to be used in these robots, for example, television screens, computers, and things like that, are audiovisual or information technology based. So because of this, UL 62368 Part 1 is used as the basis. And really, the outline of investigation then provides supplemental requirements. So in addition to that, the outline of investigation was written while keeping in mind that those who are either using the robot or are in close proximity to the robot have no special training or knowledge of the robot, and the robot must be able to operate safely in that intended environment with those untrained people. A mind map of the outline of investigation for UL 3300 is shown here. So we don't have time to go over every section of the outline in detail. However, I will talk you through and provide a summary of some of the more important sections, definitions, and terms that are used in the outline. First, there are safety concerns with some of the non-robotic items. So we know that batteries and cells, for example, particularly those that use lithium-ion technologies, are potentially susceptible to fire and explosion hazard. So there are some requirements related to batteries and cells. Power supplies and chargers that are used to charge those same batteries and cells also potentially have fire and electric shock concerns that also need to be addressed by the design. We saw that some of the robots, like companion robots, could have textiles that could present a fire hazard. There could be other things related to textiles that could pose some sort of hazard as well, such as could serve as a toxicity hazard if the robot is intended to come in contact with humans. So the robot may also emit things like loud noises or lights or lasers, things like that, hot and cold temperatures, also things like that, that could potentially be painful or injure humans. And also, it may be necessary for the robot to be provided with appropriate markings or instructions that are there to be able to warn users or let them know of some sort of potential hazard that's related to the robot. So these are the same types of hazards that could be present in almost any other audiovisual or information technology application that would be covered under UL 62368 Part 1. However, we're still missing something. Products covered under UL 62368 Part 1 aren't mobile. Robots, however, move. And because robots move, they could potentially collide with objects and humans, and that can pose a potential safety risk of pain or injury. And robots often are autonomous in nature and are able to decide for themselves when and how to move. So these decisions, these autonomous decisions, may have an influence on whether or not the robot is operating safely. Because of this, the outline of investigation of UL 3300 has specific sections that address risks related to mobility, and also the control system that is responsible for controlling the actions of the robot. Regarding mobility, the robot must be provided with certain safeguards that reduce certain risks, such as entrapment, pain, or injury, due to energy transferred between the robot and a person. And because the robot will be operating around persons who have no specific training or knowledge of the robot, these safeguards all primarily must be equipment-based. In other words, they're designed into the robot itself and not just instructional. We aren't relying on a user manual or markings because, frankly, a child is not going to have time to read or understand a marking or instruction manual when that child encounters a robot. So the requirements and tests in sections 7.2, 7.3, and 7.4 are applied based on two main factors, things that we are going to talk about next: the robot's operational design domain and the robot's type. And as I said, we'll quickly summarize these two things next. So first, we have the operational design domain, or ODD. The operational design domain can be thought of as a description of the environment in which the robot will operate. You could think of it as the who, the what, the where, the when, the why, and the how of the robot. So, who is going to be operating the robot? What's the robot going to be operating around and with? What will the robot be doing? Where will the robot be operating, including its location and the objects in that area? And then also possibly things like under what temperature and environmental conditions. When will the robot be operating? Could be during the day, could be at night, could be when people are around, maybe when they're not around. Why is the robot needed to perform its functions? And then perhaps how exactly the robot will accomplish its goals. For example, what kind of control systems and safety-related control functions does it have? So in addition, there is something called robot type. So there are 6 different robot types defined by the outline of investigation, and these are used to help classify the robots and apply appropriate requirements to each type of robot based on the amount and the type of risk that's presented by the robot. Robot types are assigned based on a combination of a few different factors: height or size of the robot, mass of the robot, and then also, in addition to that, the maximum speed of the robot. So these 3 different factors directly impact the potential risk that's associated with and presented by the robot. The table on this slide summarizes the 6 robot types as a function of height, mass, and speed, as we talked about previously. So I'd like to point out a few things, a few different important thresholds that are used in this table. First, robots that travel faster than 0.3 meters per second are designated as at least robot type 3, since they may not be completely avoidable by some persons, such as, for example, children, and so therefore those robots pose additional risk. Robots that are taller than 1 meter in height are designated as at least robot type 4, since their size makes it more likely that they could strike the upper body of a person. And so the upper body of a person is more likely to be sensitive to impact. Also, in addition to that, robot type 4, or a robot that is taller than 1 meter, is more likely to entrap someone if they fell on a person. And then mass also plays a role in determining effectively all of the robot types, since mass directly influences the amount of force that could be inflicted if the robot makes contact with a person. Let's talk a little bit about the control system of the robot now, in Section 8 of the Outline of Investigation. So the outline contains requirements that ensure that the safety-related control functions performed by the control system of the robot, including things like robot stop, emergency stop, braking, object detection, and enabling robotic motion, all are going to be operating correctly as the robot is doing whatever it does in its own operational design domain. And it's supposed to do this under not only normal conditions, but also abnormal conditions and single fault conditions as well. Now, safety-related control functions in a modern robot are most likely going to be utilizing some sort of embedded system that is using software or firmware. In addition to that, that software or firmware may be using third-party software such as operating systems, or it may also have the capability to be updated remotely. So therefore, the outline of investigation is going to specify additional requirements for things like functional safety, making sure that the safety functions perform correctly, requirements for third-party software to make sure that the third-party software is operating correctly, and then in addition to that, requirements to make sure that if a manufacturer is going to be updating the software or firmware of the robot over the air, that that is also going to be done safely. So for functional safety, the outline of investigation of UL 3300 references Annex H of the standard UL 60730 Part 1, and it's going to require different software classes or levels of rigor depending on the robot type that we talked about previously. So control systems for Type 1 robots. Now, Type 1 robots are going to be short, they're going to be light, and they're going to be very slow as well. Those robots are not required to comply with any sort of functional safety requirements. Now, once we get up to higher type robots, then functional safety requirements will be introduced. Control systems for Type 2 robots are required to comply then with software class B. And then control systems for Type 3 and higher robots are required to comply with the more robust requirements of software class C. Now, UL, we have several decades of experience applying functional safety and software safety requirements for many different applications, whether it be industrial, appliances, renewable energy, hazardous locations, and things like that, and also standards as well, including UL 991, UL 1998, UL 60730, IEC 61508, and functional safety standards like that. We also offer special certification marks if a product and its control system has been shown to comply with appropriate functional safety requirements. The outline of investigation of UL 3300 for Sky Robots was actually published almost 1 year ago. So there have already been some additional changes that have been made to the certification requirements since UL 3300, the outline of investigation, was published. And some of the requirements, as I mentioned previously, are still, in fact, also in development. So I'll give you a little bit of summary or background of some of these things that have changed already. So first of all, some changes were made to more fully develop requirements for Type 5 robots that operate indoors. previously these requirements were to be determined. However, UL thought that these types of robots were similar enough to Type 4 robots, and particularly if they were just operating indoors, and wanted to fully flesh out those requirements and differentiate those Type 5 robots from outdoor types of robots, and then also Type 6 robots that could, for example, be delivery robots that could cross or travel on public roads. So those particular types of robots that would cross or travel on public roads obviously are going to present additional risk and additional concerns of avoiding automobiles and other vehicles like that. So we've also taken some steps to revise and clarify the requirements for over-the-air software updates. So those requirements are going to reference the standard UL 5500. There has also been an additional annex of requirements that has been created to address robots that are capable of performing aerial operation, such as indoor drones and things like that. Now, the scope of aerial operation right now is constrained to smaller robots that are operating in an indoor environment. And then lastly, the requirements for manipulators. They were initially to be determined and haven't been developed yet. And these requirements are actually still in development. However, they'll most likely remain undefined and unpublished for the time being, and they may not actually be completed until the consensus standard has been published. And we're actually going to be talking about that next. So as mentioned, we're now going to talk a little bit more about the consensus standard process and how UL goes about developing a consensus standard, including UL 3300. To create a consensus standard, UL will first form something called a Standards Technical Panel, or STP. An STP is similar to an IEC or an ISO technical committee, and it consists of a group of people from various different backgrounds and companies. So normally an STP consists of no more than 30 members. It can be a little bit more or usually a little bit less than that. So the STP potentially includes, as I mentioned, groups of people from different areas: producers, manufacturers, authorities having jurisdiction, other testing and standards organizations, and consumers. One important note about the STP is that it must be balanced before work on the consensus standards starts. So each interest group typically is going to have no more than 33% of the total number of members in the STP. And this is done to reduce specific bias. So that 33% is not a firm rule, however, it's a general guideline. So once the STP has been formed, the STP is then tasked with writing the consensus standard. And usually we start off with some sort of an initial draft called a seed document. So in the case of the consensus standard UL 3300, the seed document that we used actually happens to be the outline of investigation that we already talked about. So once the STP has worked on and completed all of the different parts of the standard is then finalized by the drafting committee and then formatted for final review as a UL consensus standard and to be potentially published. So then each of the STP members has a last chance to provide comments make suggestions, and then ultimately vote to accept or reject the proposed standard. So during this process of writing, finalizing, and voting on the standard, the STP is going to be periodically meeting to discuss the contents of the standard and then also perform other tasks to facilitate completion of the standard. So then the results of the vote are then tabulated and determined. If the vote does not pass, the proposed standard is recirculated to address comments that were submitted. Then potentially changes are made to the standard, and then another vote could then take place. This recirculation process could actually take place multiple times. However, if the vote actually passes, the standard is then published as an official UL consensus standard. And normally, once this process is successful, it's typically going to take anywhere from start to finish from 12 to 18 months, though this could take shorter or longer in unusual circumstances. Here's a closer look at the STP members for the consensus standard UL 3300. So note that not all represented companies are shown on this slide. You'll notice that this particular STP for UL 3300 primarily consists of producers and manufacturers, and then also testing and standards organizations, and is also represented by companies all around the world, particularly including Asia, Europe, and North America. So where are we now in the consensus standard development process for UL 3300? So the STP was formed at the end of last year. The first STP meetings were then held in the first few months of this year. With the outline of investigation that UL published, we talked about previously, that has been used as the seed document for the consensus standard. A small group of STP members called a task group was then formed to help refine and clarify the scope of the standard. So the task group worked on the scope in April through June of this year. After the scope task group finished their work, the STP continued on with their meetings, and we currently have several additional meetings scheduled in August and September of this year. If all goes well, we hope to have a published consensus standard sometime next year in 2022. But for the time being, the outline of investigation of UL 3300 that we talked about previously is now available as a published document for a UL certification mark. Recapping everything we've discussed today. So first of all, UL determined that a new standard was needed to address risks presented by consumer or sky robots to humans. UL then published an outline of investigation as an initial version of the standard that can be immediately used to evaluate a robot for a certification mark. And that outline contains requirements that ensure that the non-robotic, the robotic, and the safety functions of the robot perform correctly and do not present a risk. In parallel, UL has formed a standards technical panel to develop the consensus standard UL 3300. And we hope that this consensus standard will be published sometime next year. So I'd like to thank everyone for their time and for listening to me. I really hope that this was an informative and interesting presentation about UL's efforts to publish a consensus standard for sky or consumer robots. Thanks again, everybody.
家呢，他来跟我们大家分享一些这个机器人安全的一些制定的标准。那接着下来呢，我们也是一样，再让大家休息10分钟的时间，然后一样，在50分之前回来，我们会进入到第4场的专题演讲。好，那我们现在可以直接休息到1点50。 好，那么继续回到我们的国际研讨会哦，接下来第4场的专题演讲应该也是非常非常的精彩。这次呢，我们很荣幸可以邀请到是以机器人触觉系统、还有非线性跟模糊控制理论为专长的我们的元件精机的苏瑞瑶董事长。那其实他接下来可能会跟我们分享的是，比如说以这个机器人的触觉技术来发展感测器，还有比如说一些人机协作智慧制造的一些整合的技术应用。那接着下来，我们就热烈的掌声来欢迎苏董事长。
OK， 在场的先进贵宾，然后在直播现场观看的各位朋友，大家午安，大家好。很高兴今天有这个机会来跟大家谈接下来的这一个主题。我们谈的是迈向人机协作的这个趋势，特别是针对ISO 国际安全标准我所收集到的一些资讯，跟大家做个解析说明，还有在技术上面我们可以如何去应用它。那我是元件精机的苏瑞瑶。那后面的在开始后面的简报之前，我大概先做个简单的自我介绍哈。我个人是电机博士毕业之后，从2009年就在工业技术研究院的这个机械所参与机器人，尤其是触觉感测技术相关的这个研发工作。那工研院我们也在2015年成功发表了第1代的工业用机器人可以上面的安全皮肤哈。那2017年我们从工研院 spin off 创立了元件精机，我现在是元件精机的董事长兼策略长哦。那从2018年也获这个自动化协会的邀请，担任这个标准委员哈。那其实从在工研院的时期，从2016年开始，我们就几乎每年都参与了国际标准组织 ISO TC299 机器人标准委员会的一些会议尤其是WG6这个工作小组。那因为台湾的机器人的技术获得这个主席的一些肯定所以我们有这个机会都能够参与这样子的一个工作会议那从我投入职场以来过去10几年几乎都在研究机器人以及机器人的触觉技术。那希望有朝一日可以让这个机器人的应用能够跟这个社会、跟我们各个每一个人能够有更紧密的结合那尤其是现在我们都知道智慧制造，应该说制造业是国家经济的一个很重要的动脉。那怎么善用机器人、善用机器人感测器，能够让整个制造业的这个情况带来一些转变OK， 那不好意思。那元件精机从2017年成立之后，其实我们发展的第一个T-skin 安全皮肤，在当年就已经通过了ISO TS15066有一个人跟机器撞击的这种碰撞测试了那也在2018年陆续跟这个国内的几个机器人品牌商大家一起合作为他们的工业型机械手背开发这个安全皮肤那2019年治安署修正新的机器人灾害预防标准的那一年的当下，佳士达 ABB 也发表了第一套这个全台第一条人机协作的产线。那这个也是由 PMC 这个参与认证的。这个等一下在下一个演讲章节李处长应该会再说明到这一点那2020年开始，这个我们元件精机推出 To Share Solution 这个品牌应该借由Touch 这样的一个形象，让大家可以更直觉的连接到这是跟机器人触觉相关的一种技术跟产品。那佳士达的这个协作产线以及这个 T-skin 的这个产品，也获得 IFR 的新闻刊登在那个协作机器人应用的这个首页那今年2021年，我们刚拿到第1届经济部工业局举办的首届机器人智慧系统优质奖，我们是这个关键零组件的这个优良奖，那也很感谢大家的肯定。那好， 今天的等一下后面的提纲啊，接下来的大概40分钟，我大概会提这3个主题啦。那第一个是提到智慧制造的新的面貌，迈向人机协作的这一个趋势哈，是这个大的 mega trend 从2015年，从2014年开始一直到现在2021年，有一个很明显的趋势，协同作业，还有或者是俗称的人机协作，会是一个越来越重要的主轴。那在第二个部分，可能是主要的部分，就目前ISO 10218就是机器人相关的这个国际标准，我进行一些说明哈，还有它里面所涉及到的这些安全技术的一些重点 ，OK。那最后我们会以这个工业机器人如何在合乎这个协同作业安全，然后又能够在产线上面这个整合应用给出一些样态 ，OK。首先我们第一个部分我们谈的是智慧制造的人机协作的趋势啦。我想这个很明显的图片啦，大家都可以理解。过去想到制造业，要么就是手工组装，那手工组装的时候就是产线密集的都是人。那如果一想到机器人，过去的机器人用的是在隔离的状况之下做的全自动生产，或者是很直觉联想到的无人工厂、无人自动化。那无人自动化的这一些机械手背，也就是被隔离在栅栏里面使用的手背。所以过去我们面对机器人这样的一个生产设备或者这样生产工具，我们的做法是把它跟人隔离开来哈，这个作为一个间接的工具来使用哈。但是考虑到全球制造业面临到新的挑战我们常见的挑战不外乎几个一个叫做少量多样的这个从大量生产变成大量客制，尤其是工业4.0之后，少量多样的这个变量变样的弹性生产的样态，要的是这个竞争力，要的是弹性，要的是配适性，所以这样的需求会让传统你要完全无人生产的自动化的这个导入的这些成本越来越困难。那在第二个是这个人口红利的不在了，不管是我国也好这个日本也好，其实即便是中国大陆也是，这个在劳动人口上面的红利都是慢慢的在缩减的。那怎么样在增加这个厂房的生产力的同时，又能够避免掉这个人口红利的折损所以如何善用机器人来导入到制造业的一个生产环节，就是这个制造业还蛮重要的一个挑战。话约来说啦怎么样利用人跟机器，不外乎我们就考虑这几件事情。第一个怎么样确保它的安全安全最重要。再第二个怎么样善用这个空间，让人跟机器有一个这个更节约的空间可以配置。那第三个是整个生产效率。第四个可能是这个系统整合业者或者是业主比较在意的，整个自动化的成本有如何做一个更优化的配置，尤其是弹性生产制造的时候，产线可能都是变动的。人跟机器，机器跟工件就是要做的成品跟物料跟仓储，这所有的环境都是变动的。在变动的环境之下，你这个固定式的配置，它的这个自动化成本相对的是笨重而繁琐的那考虑到这几个面向，一个新的名词就称之为人机协作，那简称叫 HRC， 其实就是 Human Robot Collaboration。那白话来说，就是有没有除了人跟机器隔离之外，一个可以让人跟机器人共同参与的生产制造环节。这是有机会的我们看到电影里面这个星际大战或者是其他的卡通，你看到机器人应该是人类的一个好帮手，它应该是在人类的旁边担任我们的这个协助者的角色嘛。所以过往以来一直把机器跟人用隔离的方式，这个好像就不太符合我们的期待那更确切的讲，应该是这样了，在整个制造生产的过程当中，其实人跟机器扮演的角色可能各不相同人类比较擅长的应该是判断，我们的这个敏捷的判断力，还有我们调整的这个能力，还有我们的弹性以及适应力，这是人类在从事工艺生产的时候所扮演的主要的价值。 那在整个工序当中，一些比较枯燥的、重复性的或者是危险的工作，就是笨重啦、重复啦、枯燥的工作，这种东西，如果可以透过机械设备或透过机器人来代为执行的话，那整个劳动条件会更加的轻松一点哈。所以这个如何善用一个生产制造的这个环节，让人跟机器都各自扮演角色，这个是一个新的制造样态的思考。那当然以欧洲来说，会说以人为本啊，这是制造业的文艺复兴时代，以人为本的这个自动化或以人为本的智慧制造，怎么样让机器变成人的一个更好的工具哈？那结合聪明的敏捷的人，还有这个精良的机械设备，大家一起参与到制造现场。那这边这个图哦，这个讨论很久了，其实是大概2016年就出来的图。这个图大概很简单的说明一下，所谓的人机协作，狭隘的直观的误解会认为人机协作是人跟机器一起做一件事情，但实际上所谓的人机协作还包含在这个空间中，因为没有隔离，所以人经过机器手背工作的地方，这个叫 coexisting， 是共存。过往人跟机器是隔离开的嘛，但即便是这个场所，机器做机械手背做机器手背自己的任务，人经过，可是因为没有隔离了，所以这一种环节也被纳为人机协作的一个范围。另外一种，或者我觉得可能比较适合，或者在这个智慧制造的时候更常见的，是人担任介入者的角色啊。机械手背在做他的工作的同时，这个人担任这个领班或者是这个小组长进去督导他、调整他、介入他的工作，担任一个协助者的角色。这种人介入到机器手背的运作，这个也是一个这个人机协作哈。所以人机协作不是那么狭隘的，就是我跟机器一起握手工作，不是这样的哈。其实应该是当你打破了这个人跟机器的隔阂之后，所有可能人跟机器共存在一个工作现场的，都是人机协作的范畴。这样讲可能有点抽象，但没关系。如果我们以这个制造业的光谱来看的话，大概可以这样讲哦。这个出处在底下哦，大家可以上网去找。意思是说，不管是完全自动化无人，或者是完全依赖人的制造业，这中间总有很大的一个区域是妥善的配置人跟机器的比例，去共同参与生产。这一个环节就是人机协作的未开发的一片这个新的应用场景哦。那所以只要人跟机器可以在同一个空间中工作，那这个我们就称之为这个协同作业或是人机协作。那 IFR 有一个预测啦，其实这个 MIC 有做一个统计，大概在5年内，大概机器人会有将近23%，就将近1/4都会是在人旁边工作的。所以人跟机器的隔离，一直到在5年之后，大家可能可以看到人就是机器是机械手背，应该是很自然而然的就会在人的场域里面出现的。比如说底下左方这张图哦，这是一个汽车产线的这个汽车产品的这个组装，应该是半把。看到其实人跟机器是各司其职的哈。人把一些这个管线比较灵巧有弹性的这些异形件，由人来进行主力。然后机器擅长的是它会检查，它可以做精密的取样检查，好去做核对。所以人跟机器共同做完了这一个工作，这个就是传统过去你要完全靠人做人检查，或者完全要找机器人来做这一个配置，这几乎过去不可能的事情。现在你让机器跟人各司其职，这个就很有应用的空间哦。那在这所有的发展里面，既然人跟机器要共用同一个空间了，我想这个安全就是最重要的议题哈。那也由这一点我们来带入这整个ISO 标准，最主要谈论的就是人跟机器共存的时候有哪些安全议题要考虑。那这边还有几个名词也跟大家做一个定义啦 在这里我们所提到的协作机器人或是协作用工业机器人，其实通通指，因为 ISO 规范的是工业环境之下的这个机器人安全，所以应该是这样，在机器人的范畴里面，你有应用到协同作业的这一区，就是 IFR 或者就是国际这个安全标准10218所在意的，称之为协作用的工业机器人。那有一些协作机器人是不在工业里面使用。那至于工业跟非工业其实前一个那个讲者 UL 的讲者也讲得很清楚了，你是对特定对象的，像工厂里面我们的对象就是作业员或者是这个劳动参与者，这个是特定对象的，就叫工业用。但是像前一个讲到的 UL 3300，它对应的是开放式的，它是游客啦，不确定人，没有受过训练，不知道怎么使用机器人的这种，它叫做非工业用。那非工业用自然有别的领域的标准在关心，但这边 ISO 跟 IFR 我们在意的是在工业的这个category 之下，你有协同作业应用，那这个就会是整个 ISO 的标准的这个在意的点哈。所以由这个名词，我们再来看，其实我们现在署里面正在推动，就是所有在工业环境之下使用的机器人，应该都要符合这相对应的国际标准，指的应该就是说在整个工业环境里面使用的机器人，至少都要符合这个工业用标准哈。那另外一个名词或者另外一个概念要谈的是人跟机器之间的这个安全概念。我想这个图其实很简单的说明了，从完全是机器没有人，到人跟机器可以无缝的这个配置在一起，这个过程其实就是把机器就是0跟1在0跟1的中间怎么样去实现人跟机器的一个 HRC， 也就是协同作业。那底下这个图可能更明确的讲，其实呢，我们要讨论的事情就是以前就是把人放到机器的空间里面这一个事实。只要人跟机器在同一个空间，可能的空间、可能触及的空间，或者是可以防护到的空间，这个在后面会有再仔细的定义。只要人跟机器在相同一个空间，那这个就是 HRC 要去规范的安全事项。那专业一点的定义大概就会有2个名词啦，一个叫做协同作业应用，那后面会有更仔细的说明。但我们现在有个概念，一个是指这个应用，因为机器人的工作或者机器人的应用不见得是协同作业嘛，比如机器人完全自己工作的话，那它就是全自动应用。那如果你的应用里面的某一个部分会涉及到有人共存在同一个空间，那这个集成应用就算是协同作业应用。换句话说，这机器可能20分钟都是自己工作的，但是它后面有1分钟人跟机器会一起进来，那这整个流程就把它适用在这个协同作业应用的这个考量里面。那在第二个，你的工作的空间，人跟机器会共存，那这一个生产工作期间，他们共存以完成任务的那个空间，就称之为协同作业的工作空间。大概就是流程、动作流程跟空间这2个概念来构成了整个协同作业最主要的安全。那其实 IFR 也帮大家整理了一下，我们可以去推估或者是去观察未来人机协作应用的方式会如何发展。这张图简单说明一下，我们把这个横轴当成人跟机器合作的这个紧密的程度，那所以纵轴把它当成这个所带来的这个生产价值的这个高低哈。那以这张图来看，传统的做法，人跟机器各自隔离开来，它的这个生产效能是固定的。因为人跟机器是各自做各自的嘛。那协同作业的这个情境的第一个类型叫做共存 coexistence， 就是这个的中文翻译，因为还没有 我目前还没有看到统一的翻译名词，所以我就先不翻译了。但我们可以去理解它的意思，就是人跟机器共存，但是各自有各自的空间。哦，那起码这个就少掉了隔离哦。那这个人跟机器一起共存，没有栅栏。哦，但人跟机器的各自的工作空间没有重叠。第二个再更进一步sequential collaboration 就是这个时序性的这种协同作业，人跟机器的工作空间在工件或在工作范围这里有重叠了。那这一个协同作业空间，人跟机器可以依序，比如我做完了，换机器进来做啊，他们共用了同一个空间，空间上面有重叠，这个叫那时间上面是依序的，顺序式的，这叫 sequential collaboration。那更复杂一点或者可以是人跟机器是一起同时并行做这个生产任务的，所以一排的工件，人是依序做，机器也同时在做所以这个人跟机器同时并存，这个是 parallel。那更理想一点呢，应该是机器手背能够迁就的人去做这件事。比如说我摆左边，他到左边来工作；我摆右边，他到右边来工作。在这个过程当中，人跟机器同时对同一个工件进行加工或者处理。这里面所有的协同作业，它大概就只在乎，我们可以看到它只在乎空间上面的重叠，还有时间上面的重叠。空间重叠越多，时间重叠越多，这个人跟机器的这个合作的能力就越强，所带来的产值就会越可观。那在整个协同作业的情境里面，人跟机器的接触是不可避免的。所以如何确保这个人跟机器能够让人跟机器安全的接触，安全的完成这个流程，这个就是整个协作应用所要留意的这些议题。OK， 那简单就大概先给个就是 concept， 大概就讲到这个。所以协同作业讲的就是人跟机器在同一个空间，或人跟机器在同一个时间上面有所重叠那 ISO 这个10218过去是在规范这个机器人跟机器人系统相关的这个标准的。那也针对这个协同作业的这个趋势，其实最近做了一些改版，简单跟大家说明一下。那提到工业用机器人的安全的国际标准呢，就是 ISO 10218系列。那系列指的是 ISO 10218-1，那ISO 10218-2。好，那-1专门针对的是机器人单机的这个国际安全标准。那10218-2指的是机器人系统，还有机器人的应用，也就是系统集合、系统集成。那这个系统整合相关的安全标准就都写在-2里面。那因为协同作业的兴起所以有一个补充的这个技术规范TS 15066里面就规范了。那在刚刚提到的空间的重叠，还有时间的重叠上面有没有哪些安全准则要去遵守的？就作为一个补充文件写在 TS 15066那这个是过去这个10218系列的这些大概是3大主要的标准那这个标准ISO 的 TC299是个很特别的组织我想相对于 IEC 或者其他的这些国际标准来说ISO TC299的第一的核心任务是要让这一个机器人标准成为一个调和标准，所以调和标准就是可以放诸四海皆准的标准。所以其实现今这个ISO 10218系列标准不管在北美、在中国、在这个欧洲，或者是在日本、南韩，甚至台湾，甚至英国还有巴西、纽西兰、澳洲等地，都采用相同的标准了。虽然我们转换之后的 code 不一样，比如说像台湾叫 CNS 14490，但其实它的内文精神跟它内文的这些注意事项都是一样的。所以作为一个全球最多国家采用的这个调和标准，机器人这边做的其实是比工具机或是其他的机械设备更统一的，更一致性的，这是一个好事。这对我们做 机器人相关的这个业者，或者是应用机器人的使用者，这都是好事哦。就代表这个ISO 标准其实是可以仿诸四海皆准的标准。那这个标准刚刚所提到的那个1.28-1-2还有15066，前一个版本是2011年的时候颁布的。那其实今年2021年已经有刚完成投票了，所以很快今年就要改版了。明年ISO 102182022年的版本就会出来更新掉国际这个标准。那这次的改版里面，相较于这个2011年的版本，就特别提到有三大更新项目。第一个，已经正式把协作应用的这些精神跟条文放到这个10218的文本里面了。也就是说，以往是作为补充文件的15066呢，里面所提到的这些安全注意这个指导原则跟这些规格，都已经放到了正式的文本里面去了。再第二个，也采用 functional safety 的概念，的这个观念不是概念，更明确的将所需要的这个安全需求都写定在新的这个ISO 文件里面了。那最后也呼应到，其实我们上午有提到的这个网络安全，然后 Cybersecurity， 因为机器人系统作为自动化里面最灵活的一个载台，那它势必跟 IoT 也会跟未来的这些联网资讯安全、网络安全都相关，所以它也把这个 Cybersecurity 也把它放进来。这大概就是明年会推出的新的版本的这个 ISO 10218。那在这个文本的一开始，他也开宗明义的再跟大家重申一遍哦，我们这边不谈协作机器人，其实在工业的场域里面，我们谈的应该是工业机器人的协同作业应用。所以它的名词就讲了，它叫做 collaborative application。我们针对这个 application， 我们来探讨一下安全要怎么样被落实跟确保哦。那我这边就最后摘要出来哈，大概有几个概念，大概是这样。我们提到一个名词叫机器人，就是 industrial robot， 指的应该就是指机器人手的本体，加上控制器这个硬体或者这里面基本的运作的软体。这个部分在定义里面就叫 robot 或叫 industrial robot。那如果你再加上夹爪，还有你的周边的设备，还有为了跑这一个工作所写的程式，这个 program， 这个就叫机器人系统。它的概念就是这样，这是系统。再来，如果你考虑到系统之外还有工件，因为工件可能大大小小嘛，可能危险不危险，可能轻或重。考虑到工件，还有在这个周围的障碍物，包含人，那这个就叫一个机器人的应用。所以当我们谈到机器人应用安全的时候，我们就要考虑到机器人控制器、机器人夹爪、机器人旁边的设备、它的工件以及人，这整个就是一个应用的安全。那再考虑到所有的防护作为，包含你所拉出来的防护空间，还有你的防护的装置，这个就是一个完整的机器人 robot cell。所以在整个文本里面，当我们谈到 cell 的安全、application 的安全、系统的安全，我们就可以抽丝剥茧，一个一个进来回来看。OK， 好，大概就是这个新的文本的这个concept。OK， 那相较于以往，那我们要讨论这个机器人跟人的空间，这空间就复杂多一点了哈。以前我们只在意机器人到底占了多少空间，或者机器人的手背它占了多少的空间。那现在考虑到刚刚所提到的机器人的 cell， 人机协作的这个 cell， 我们要考虑到的就会还有更多衍生出来的，称之为安全保障的空间。所有你有采取安全措施的，不管是扫描，像刚刚我们在外面有看到扫描式的这一些装置，它都可以把机器人的运作空间之外，再延伸出它的保护空间。这个都是有效的一个作为，这也是我们在标示空间的时候要加以理解的。所以其实整个机器人cell 的安全，或整个机器人协同作业应用的安全，已经不再只看机器人本体了，而是从人开始出现，一直到越来越靠近 你的工作区域的时候，这整个过程或者这整个环境都是这个协同作业空间可以加以去遵循，加以这个按照规范去把它实现出来的。简单的图大概是这样，灰色的空间是机器手背可以运作的最大范围。那么我们可以因为程式的关系设计这个机器人要真正工作的时候的限制空间。那白色的部分是机器人跟人要完成这个工作时候的作业空间，然后这个黄色的这第4个部分是衍生出来的安全保障空间。在安全保障空间的边界可以实施栅栏或者做标记标线，去说明你一旦进到这个范围，你就在我的安全保障的考量之内了。那在这个文本的附件里面也很明确的说，不要不是只考虑灰色的机器人的这个运动范围，我们考量的是有效的安全防护或者安全保障空间，就是这个黄色的这个部分。只要在这个黄色的空间实施足够的这个安全作为，那协同作业就允许人跟机器更紧密的这个接触，不管是在工作空间之外在限制空间之外，或者在限制空间之内，人跟机器的接触都是可以的都是可以的。意思是说，你的安全防护作为够周到的，够这个周延的话，你就不用去刻意阻止人跟机器的接触。OK， 好，那有这个概念，我们再往下看。在以前15066刚出来的时候，待会我们大概提到协同作业，大概会提到4个功能啦。那其实新版的大概就把它再去无存精一点的这样讲。我们讲到协同作业，大概会有3个很特色的安全功能这个是新的编码，没关系。大概第一个指的是这个SSM， 就是空间跟这个间隔的监控功能。简单的说，这个机器人的运动呢，会去随时监控它目前的速度，还有你跟它的相对距离。你跟它离得越近，这个机器人就越慢，或者是就越小心。这种功能就是 SSM。第二个是这个hand guiding 啦，就是人可以直接接触到机器，让手动去引导机器运动这件事情。那第3个是 power 跟 force limiting， 就是能量或者是功率跟这个力量的限制。这个是指会接触的时候一定要考量你的这个力道的大小。后面大概花一点篇幅再仔细的说明一下。所谓第一种安全功能，协同作业应用里面可能会有上述的几种安全功能，不必然要都有，也不必然是只有这个不可以有那个。现在讲的是在协同作业里面我们可以考虑到的这个安全功能可以有这几种。第一种这个 SSM 其实很简单啦，我们可以画一个轴来看，横轴大概就是人跟机器或是人这个进入到那个空间的这个远近，越靠近0就是越近。那纵轴就是机器目前运作，就是机器手背目前运作的速度。那 SSM 要做的事情其实很简单，在人在一定的距离之外的时候，机器可以全速没什么关系。但一旦它侦测到你开始靠近了，这个机器手背要开始降速。那在你还没有来得及能够碰得到机器之前，这个速度要降到0就静止。所以等于你靠近还没碰到它，这个机器人要能够先停下来，这叫预防性停止或保护性停止。因为我这种功能，这也是一种符合这个协同作业应用会常用到的这个行为。那第二种，刚提到的这个手动导引控制，它的限制是这样的：一旦你要启动这个使用手动导引控制的话，机器人一开始速度是0它是不能动的，所以等它在静止状态之下，让你去手动引导它。一旦你跟它碰到了，开始推它或者开始操作它，这个速度才可以拉起来。那这个速度也不能太高，它也有一个这个教导速度。但是在你还没有碰到它之前，手背要在静止的状态。 所以目前安全规范不会在一个运动中的手背让你跟他打太极拳去教导他这个不要这样，这是不要这样，先静止，然后你再去切换变成这个手动引导，这是安全规范。OK， 那在第三个比较关键的，或者是我觉得我们应该会最常用到的，是不是如果人跟机器的接触不可避免那你的这个撞击的力量一定要小于一定要小于它这个文本里面规范的值那关于这个值这个从很早以前就开始研究人跟机器怎么撞才是安全的这个当然都是不安全的啦这个还蛮早这好像2008年的时候德国就开始研究人跟机器发生撞击的时候，就像汽车撞到人的时候会对人造成多大的伤害，那怎么样去让人跟机器的互动是不会伤害到人的，这看起来都很恐怖，所以我们往下看好了就结论来说应该是这样，好吧？如果我们要设计人跟机器是在协同作业之下安全的撞击，或是这个撞击不会对人造成伤害，那这个值就要把它定在人能够忍耐的疼痛的上限，不要造成轻伤，也不要造成这个不可回复的伤害，也不要造成重伤。所以所有力量大过人能够忍受的疼痛极限的这个值，只有比这个更小，我们才可以把这个力量纳入到这个协同作业的规范所以后续大家都会看到这个人跟机器的接触，大概机械危害就分撞跟夹嘛就是撞击跟夹击。透过这个缅因兹大学的这个研究，在 ISO 10218-2或者是以前的15066里面，它都有一个名词，就是人体冲击的极限表。针对撞击或夹击，他们是这样研究着：把人的身体部位分成21个部位，根据不同的部位去测量人的疼痛忍耐的程度，给出了这么一张表，叫做 Biomechanical Limit。针对撞击跟夹击，举个例子来说，人的最脆弱的部位是腹部，腹部发生夹击的这个压力上限是每平方公分140牛顿，或者你的撞击的力量上限是110牛顿。意思是说这个夹击啦110牛顿大概就11公斤嘛。我常常举一个例子，大概就像是一个还没上小学以前的小朋友踩在你的肚子上面，那一个力量的大小就是11公斤。11公斤应该更小反正就是11公斤的力量踩在你的肚子上面的这个力量大小，就是人的腹部的夹击的忍耐极限。那撞击可以允许有瞬间2倍的力量，所以撞击的那一刹那可能是220牛顿，然后只要能够在0.5秒之内力量获得解除，它就会进入夹击状态。所以对于撞这件事情 ，ISO 已经有了很明确的规范就是在这个15066或在这个10218-2的附表里面针对你在刚刚讲到的人跟机器的这个重叠的空间当中，你会发生这个机械危害的部分，可以根据你撞击的部位还有撞击的力量去做这个风险防护那所以在整个协同作业里面，其实系统整合商扮演一个还蛮关键的角色，就是如何去设定安全空间，还有如何设定这个机器人运作的安全速度，这个是协同作业应用的关键参数了这个刚刚讲到隔离一定是从很远以前就开始隔离，降速还可以有一些这个争取缓冲的一些空间。那如果是这个 hand guiding 的话，要从0开始启动。如果你有 power 跟 force limiting， 那机器人不必然要在你靠近的时候就停，而是可以维持一个安全速度在运作。所以大概这几个参数点的设定，就会是协同作业应用上面还蛮关键的一个角色。那回到本质安全防护的观念来看不管你是有没有共用工作空间，你是 coexistence 或是共用的工作空间之后变成sequential 的合作，或者你有物理的接触、实质的接触，机器跟人会有这个物理接触的可能，这一些甚至进一步人跟机器互动的时候使用 hand guiding， 这种人跟机器接触的 频率跟机会越来越繁重的情形之下，这个 power 跟 force limiting 都是最基本的一个防护啊，因为人跟机器会发生接触，那接触你只要确保你的撞击力量不要对人造成伤害，这个才是这个整个协同作业应用或是协同作业 cell 这一个单元里面最重要的本质安全。好 ，OK， 那后面有一点时间，我就继续介绍我们公司做的技术，应该说这是台湾的技术哦。T-Skin 就是我们刚前面所提到的，我们为机器人开发安全皮肤的目的，就是为了能够实现人跟机器发生接触的时候，为这个没有感觉的机器人提供一个感应跟防护的装置，我们称之为 T-Skin。那它可以覆盖在人跟这个机器人的表面，所以原本没有感测能力的机械手背，它的外面就多了一层像皮肤一样的这个防护装置。那整个 T-Skin 因为是针对工业用机器人开发的，所以它也相对应的合乎这个工业环境的相关要求，还有这个安全等级那这里有个简单的这个动画。那其实机器人T-Skin 连接的是机械手背的紧急停止系统。每一个工业用机器人都有一个紧急停止系统，这紧急停止系统是10218-1或者是所有机械设备都一定会有的。你可以想象以前要跑去按那个红钮做紧急停止，现在整个防护皮肤就是这个紧急停止按钮，所以你只要发生碰触，这紧急按钮就会启动，这机器人就会进入这个安全防护。那它的感度非常的敏感，那它的反应速度也非常快，也有IP 防护的等级，使用的也是工业工控系统上面的这个供电所以它在工业环境之下，可以让这个工业手背马上的启动这个停止防护，避免继续把力量作用在人身上那整个防护装置的概念大概是这样，你可以在原本的这个手背的外围逐步把这个皮肤部件上去因为它是模组化的设计所以每一个都可以单独作用，然后它整个串接起来都是一个等效的安全回路 OK。那最后再把这个安全开关直接接到这个机器人控制器的这个紧急停止接点，那这整个就是一个紧急停止系统 OK。那这个产品也通过 CE 跟 UL 相关的认证这样最主要是在机器人系统里面或在机器人单元里面，这个安全装置或者安全防护装置都要符合这个 Functional Safety Category 3 PLD 以上的要求那针对工业环境也要符合 Product Safety 那所以我们经过了一系列的认证，还包含也有请这个德国的这个皮尔兹来做这个撞击量测来确保这个整个撞击刚刚讲到的撞击的力量都不要超过这个 ISO 规范的这个人体生物极限 OK。那这边是一个影片啦这是慢动作来说明整个撞击的测试会把整个力量的动态的结果呈现下来那只要不超过那个1506规范的那个红线，那这整个力量就是不会对人造成伤害的，所以夹橘子也不会受伤那整个 skin 每一个 skin 在出厂前都会跟它搭配的机械手背进行一个量测，这量测可以提供一个这个完整的撞击测试报告，让大家知道在哪一个工作速度之下，比如说以外面的那个手背来讲，它在秒速1440 mm 的这个工作速度之下，我所撞击出来的力量都夹击或撞击都远小于这个 ISO 的标准，那这样的撞击就不会对人造成伤害。大概是这个概念，那也提供了这一个测试报告，所以业者或者系统整合业者或者是业主在做风险评估的时候，就有一个依据可以去做参考。OK， 好，那T-Skin 是目标，应该说我们现在的规划是让所有的 这个工业型机器人都有机会升级去面对这个协同作业的应用，所以所有的接触风险都可以有一个对应的安全皮肤去实施安全防护。那再具体一点的讲，我们看目前的 Cobots， 目前的 Cobots 大概它的 payload 跟它的这个精度大概都是属于比较轻，就是 payload 比较轻，然后精度比较大的这个范围，就我们机器人关节比较软，它的这个运动精度也比较中庸一点。可是你考虑到工业型的机械手背，它的荷重的范围，还有它的精密度，使用在各个生产的现场，有各式各样的机器人，所以怎么让这个所有的现场的这些工业用手背都能够有解放栅栏，实施协同作业的这个机会，这是整个 T-Skin 想扮演的角色哈。那我目前跟很多家的机器人原厂都有所合作哈。那除了跟机器人原厂合作之外，其实也跟这个周边安全防护这些系统做一个整合。刚刚提到皮肤可以提供 power 跟 force limiting 这个功能，那其他的光电这个安全防护装置，它是可以提供这个速度跟这个间隔监控这个功能。所以做这样的一个适当的搭配哈，机器人系统本身是 Category 3 Level D， 皮肤也是 Category 3 Level D， 相对应的这些安全光栅产品，它也是 Category 3 Level D， 整个系统就会符合这个机器人的安规的要求。那光栅有相对应的这个功能安全、产品安全，那其实皮肤也有相对应的功能安全这个产品安全等等。那整个系统整合起来就很符合工业用的制造业的现场。在做这个安全系统架构的时候，得到一个完整的一个控制系统，让这个手背可以马上随着人的靠近而有所降速，在发生撞击的时候，这个力量不会对人造成伤害，大概是这样的一个概念。那搭配的周边就可以因应你的现场的这个配置而有所选择，比如说选择扫描大面积扫描型的，你的场域比较开阔。或者是可以用比较精简的方式，只在局部人跟机器在这个局部工作范围里面会发生接触的，那只要配置局部的这个空间感测器，那这样做个整合，这个系统就可以让人跟机器在同一个空间里面进行生产跟制造。OK， 那当然更高端的整合，应该就是机器人如果内建皮肤的话，那这个机器人的本质安全就会获得提升了。这是我们最新发表的啦，这个是跟传奇重工合作的，在它的工业型手背上面完整的全覆盖新的这个安全皮肤可以看到它都无死角、全包覆、全弹性。这样可以让整个可以让这个机器人保有工业型的精度，这个自动化特性，同时也能够面对这个协同作业的时候所需要的这个本质安全。OK， 那最后这边再提到，其实在台湾已经有完整的这个配套措施，可以让智慧制造的现场实施协同作业了。那2018年。颁布修订的灾害预防标准里面就已经放宽产线自动化的时候，可以让人跟机器共享同一个空间。当然，这里面除了机械手背要符合10218-1的基本要求之外，那这个相对应的这些安全措施要能够符合这个ISO 的标准，不管是13849或者 TS15066的撞击要求。有了这一些文件我们只要这个按照治安署的规划完成7个章节的这些报表，我们就可以完成这个现场的安全评估报告书，就地就可以实施这个协同作业了，留存备查就好了。所以其实这是一个还蛮先进的台湾的作为，也让这个各个制造现场可以开始去尝试去思考怎么样让人跟机器做更巧妙的配置跟应用了。那最后这边有个例子，因为详细的例子等一下那个应该 李处长这边还会再做补充，我只简单说明一下，在佳士达的这个案例里面可以看到，他们采用了3道程序来确保人跟机器共存一个空间时候的安全。首先，人跟机器他们共用的协同作业空间是这个桌面，所以考虑到的撞击风险是在这个桌面的这个立方块的空间里面去实施安全防护。那本质上人跟机器是隔离的哈，人跟机器人不会有翻到这个机器人里面去的这个风险，它把它实体是隔离下来，可是它的工作空间是共用的，所以他们也使用了这个光栅系统作为这个人的这个侦测，只要人侦测到有人在这个工作空间里面，机械手背的速度是安全速度，是安全速度。那另外不管在什么情况之下，就大家看后面那个例子，OK， 比如说，人他侦测到有人，机器就降速啊；如果没有人，机器就可以回到比较高的速度去做生产，所以它的运作效能是相对动不动就停下来，它的运作效能是比较高的。刚刚也有示范的，只要发生碰触，手背都可以停下来。那个碰触的力量也都能够符合不伤害到人哦。那最大的效益啦，我想应该是这个除了空间的配置更经济之外，产能更好之外，其实我觉得最大的效益是这个，是自动化比例啊。原本这样的工序很难完全靠机器人去完成的，现在因为每一站都有1半以上是机器在共同合作，所以这个自动化的比例反而是拉高的哈。所以意思是每一站都有1半是人，1半是机器，1半是人，1半是机器。那这样的自动化又好实现，那它相对应的自动化成本也比较低，所以我觉得这个自动化比例是一个还蛮好的一个突破。OK， 好，那除了机器人本体之外，其实我们这个皮肤也有衍生到外面的夹治具了哈，这其实就是皮肤的概念嘛，把它从这个本体再往外延伸而已。那整个模组化也好，这个系统整合。所以最后做一个 summarize， 我想只要你是合格的工业型的手背，那你采用这个合格的防护作为，对于这个接触来说可以采用 T-skin， 那你的整个协作应用能够满足这个劳动部的这个安全评估报告书，那都把它完备之后，其实你就等于你完成了一个协作现场的风险评估。那在这个配置之下，人跟机器的合作就还蛮容易实现的哈。那以上简单的说明到这边。那各位如果有其他的问题的话，也欢迎上我们公司网站或者是到这个信箱提问。OK， 谢谢大家。
好，热烈的掌声，谢谢苏耀董事长跟我们来分享，就是在元件经济很多这个人机协作的一些应用案例。好，那么这个精彩的演讲结束之后，我想大家也应该需要休息一下了，所以接着下来呢，我们一样再迈入这个下个阶段的休息时间哈，我们大概给大家20分钟的这个休息。那我们后面其实也准备了很贴心的这个餐盒给大家。那我们下一个阶段回来3点钟是我们的最后一场演讲。好，我们休息到3点。 好，现在时间是2点58分，我们一样是最后的倒数2分钟。那在3点时候呢，我们会准时进入第5场，也就是今天最后一场的专题演讲。那也请听到我们现场声音的来宾们，大家把握时间，尽速入座，谢谢。好的，那么来到了这场国际研讨会的最后一场专题演讲哦，我们邀请到的是财团法人精密机械研究发展中心的验证服务处李义生处长。那他呢，除了在这个工业机械安全辅导跟验证顾问有18年的经验，那么在半导体跟高科技产业设备安全顾问也有16年的非常丰富的经验。那同时呢，处长他也担任过这个经济部标检局机械工程国家标准技术委员，所以在这个领域呢，可以说完全就是他的优势。那我们今天也很开心邀请到处长来跟我们大家分享的是国内智慧制造发展安全的一个进程，还有未来的趋势。那我们也热烈的掌声欢迎处长。
好，谢谢在座的长官、各位来宾，大家好。还有我们在线上的朋友们，今天很高兴来参加这个活动。那当然，今天这个研讨会也由精密机械研究发展中心来承办。那当然，筹备这个研讨会其实也很长一段时间。我记得去年的本来就已经要举办了那后来因为有一些遇到今年疫情的关系，所以有一些变动，跟去年的规划有一些不太一样。不过，其实今天能够顺利把这个研讨会举办到这样的一个规模，其实还是有赖大家的一个帮忙也要在此谢谢各位。那我想我先说明一下，接下来这个单元要讲的是我们在国内外的一些智慧机械发展的一个状况。那从早上的研讨会的主题 focus 在包含像我们的这个 Cybersecurity我们的资讯安全，那另外还包含了这些机器人的一些安全的一个现状，那包含我们国际上面目前的自动化的一些安全的现况。那接下来我这边提的是比较偏向整个市场趋势的一个产业动态那这里面会包含我们在国际这边机械上面的一些产业现况的资讯，那台湾机械产业的现况，还有未来我们的产业的走向。那这些未来产业的走向，其实会连接到我们未来政府单位在订定整个产业环境的一些安全上面会走到什么样的程度。那我们在订定这些劳工的一些安全的工作环境的部分，可以提供一些资讯给各位做参考。那国际机械产业现况的部分我们先来看主要的这个国际市场的一个需求，那包含从我们前3大的一个进口国就是说这都是 focus 在机械产业的部分。那前3大出口国，第1名是美国，那占了14%那第2名是中国大陆，第3名是德国。
那台湾在第14名，台湾在第14名。所以在这个进口国的部分，美国、中国、德国，那台湾定位在14大。那他们进口的部分是进口哪些机械产品？各位从荧幕上面可以看到。那美国主要是运输、能源、汽车、生医、航太这一类。那中国大陆的部分也是在运输、能源、航太。那另外还有一个3C 的部分。那德国呢？大致上也是这些产品。那台湾主要是汽车、3C， 多了一个绿能的一个设备。所以在各个国家进口从国外进口设备的部分，有这样的一个分布的一个情形。那接下来我们来看出口的部分。那世界上前3大出口国第1名是中国大陆。其实中国大陆大家也知道，销售到全世界，所以它的设备当然除了以往我们的既有观念可能是比较便宜，那在市场上可能比较有竞争力，用低价策略。那中国大陆在世界上销售就第1名所以它在出口的部分占了14%。那第2名是德国，德国各位也知道，德国的设备机械设备在世界上是很有名，它的这些机械工艺其实有达到一定的水准，所以它占了全第2名的一个出口国。那第3名是美国，美国。那台湾实际上在第18大机械出口国。其实，在我们既有印象里面，台湾出口最多应该是工具机工具机最多。那工具机里面，其实等一下我们会有一个图表，会简介各个产业设备的一个排名。那这整个机械产业来讲，我们是占全世界第18大。那当然，其他还有像日本、意大利、韩国，有各个国家不同的一个出口的一个数字跟状况，供各位参考。那接下来要跟各位说明的是国际产业的现况。其实台湾有一个智慧机械推动办公室，那当初是由经济部这边成立的。那目前的智慧机械推动办公室就设立在精密机械研究发展中心。那当然这里面就会提到智慧机械。那台湾这边谈的是智慧机械，但是在不同国家谈的就不一样的。那包含最早在德国这边所谈到的是工业 4.0， 这个是在2012年的时候推动的。德国他们把这些机械设备的一些智慧化的元素融合之后，公布一个国家的政策，定位叫工业 4.0 的一个计划。那另外一个比较大家耳熟能详的是中国制造2025。那其实世界各国每个国家都想要发展自己的一个工业设备，所以他们订定了不同的一个发展的蓝图。那包含韩国也有，韩国有韩国制造业的创新 3.0。那美国有一个 AMP 计划，那这是在2011年推动的。那泰国也有，法国也有，俄国也有，日本也有。其实每个国家都有自己订定的一些发展政策。那这些发展政策当然背后会有一些原因。那这个原因基本上我们可以分成这几项，就资讯消费的革命。因为接下来整个市场少量多样，需要客制化成为一个主流，所以必须要有更多的一些自动化或者智慧化的一些设备来协助我们的产业去做生产。那另外一个是亚洲缺工的问题，全世界其实都少子化、老年化，那整个产业都必须要升级，所以这是一个问题。另外在欧美，一个工业化的部分要重新再升级的话，要重新转型。那这个部分就必须透过一些国家政策去订定，那订定长远的计划，让整个国家的产业能够 往智慧化去发展。那我们再回来看台湾啊，那台湾智慧化总共会有几个升级的一个项目哈，包含智慧机械5大创新的项目啊，里面包含精密机械要升级成智慧机械，哦，这是最重要的一个。那我国的机械设备以外销为主哈，所以很容易受到经济的，应该说容易受到整个全球的经济的一个影响。那另外，现在我们面临什么 ？COVID-19， 还有中美贸易战的一个爆发，所以在这个部分，其实全球产业在复苏、在智慧化、自动化的需求是越来越增加。那如果说以去年跟今年来比，实际上整个产业的订单是持续有在上升。哦，其实在疫情方面也很奇怪，我们会认为说疫情的严重性好像会让整个产业受影响。但是从去年到今年来讲，整个机械产业在订单的能见度的部分其实是增加的，在台湾这个部分并没有受影响。那整个台湾的一个产业分布的部分，内外销的比例，外销的部分大概占了 70%， 那内销的部分大概占 30%。那我们总共的一个产业，应该说总共机械产业的从业人数，大概有这些人数，所以占了相当多的一个人数。那另外在分布的部分，我们分为北部、中部跟南部这3个部分。那大家也知道，中部地区其实是机械的产业重镇，所以基本上在中部地区所占的比例是最高，总共占了7000多家的一个厂商，机械厂。那北部大概7100，少了一点，南部就3000多家。那整个台湾的机械厂的分布大致上是这样。那当然东部是最少，华东地区是最少的。那这些企业里面，实际上大部分都是什么？中小企业，所以中小企业占了 99.1%， 这是2020年所统计的。所以在整个产业上面，实际上在2020年到2021年这边，台湾产业面临的问题就是中美贸易战跟 COVID-19 这边的一些影响。那基本上有下滑一点点，大概下滑比2019年同期掉了大概 6.8%。那当然整个全球的景气是逐渐复苏，那整个产业包含像美国、中国、台湾，其实大家都可以看到产业的一些脉动。接下来我们来分析各种设备、机械设备在全球的一个分布。第一个是木工机械，木工机械第1名出口最大宗的就是中国大陆，那第2名是德国，第3名是意大利。那目前台湾出口的这个排名是在第4名。如果以木工机械来讲，那比重占了全球的 9%。那如果以工具机，因为基本上我们大部分常常在提的机械，如果在中部地区，大家都会以工具机为主。那工具机的部分，在全球排名的话，第1名是德国，第2名是日本，那第3名是中国大陆，那台湾是排第5名，占了 6.1%。OK， 那如果以橡塑胶机械，德国第1名，中国大陆第2名，第3名日本，那台湾是占第6名。那半导体设备，现在最夯的半导体第1名是日本，第2名是美国，第3名是荷兰。那其实台湾也不错，台湾也有第6名，所以实际上在台湾在半导体设备方面，其实也有一定的程度可以做出口。那工业机器人的部分，这关系到今天很多议题都谈到工业机器人。那工业机器人里面最大的出口国是日本，占了1/3， 33%。那再来是德国、意大利，那台湾也排到第9名，占了 2.6%。那这个是 在台湾各个不同的领域啊，不同的设备啊，包含机器人的这个在世界各国排名里面的一个占比。那接下来，台湾的产业面临哪些？哦，还有世界的产业面临哪些的一个考验啊？那全球不确定的一个风险，这里面可以分成几个面向，那包含疫情啊。疫情的发展普及率，但目前的疫情基本上已经有一定的控制了哈。那包含整个疫苗的一个推出啊，那疫苗的普及率，那让整个原本可能经济线路要封锁的部分，可能可以解封了啊，部分解封，那这个可以让整个经济能够再活络起来。那另外一个是金融市场跟实体经济脱钩，就是在一些银行紧缩放款的政策下，当然这个是整个大环境，包含整个美国的一些财政的一些政策，那影响到全世界的一个发展。那另外在经贸政策不确定的部分，包含像刚刚提的美中经济冲突、贸易战，还有美国拜登时代，它可能有不同的一些政策在推行。那另外政策的不确定性包含日本有一些政治的一些影响政策方向的一个调整这个都是影响整个全球的一个发展的一个状况。那台湾的部分呢？台湾当然分成内部跟外部那内部的部分能量有些不足，那包含中小企业的研发能量可能会有一些缺乏还有一些资源，在智慧制造、智慧机械上面的一些资源有一些短缺。另外在市场的一个掌握度，包含人才，其实大家都知道人才荒现在非常缺人才整个产业其实都非常需要有专业人才投入，那这个部分其实是一个很大的问题。那另外在智慧机械的环境的建制还没有完备，那这里面就包含什么？感测器 sensor， 那有一些通讯的一些界面，那包含其他的一些在智慧机械上面所需要的一些元素一些零组件的一些技术，那台湾目前还需要加强。那另外在产业面临人均产值、劳动力不足的状况下那这个是内部能量的不足。另外在外部竞争激烈的部分包含在欧美各个国家，实际上其实都会去抢食这个市场其实一直都是在竞争的一个状态之下其实全世界就是一个竞争平台，那每个国家看要端出什么样的菜能够用比较低的价钱，然后提供更好的服务跟更高的技术那这是一个外部竞争的一个市场。那另外在新兴国家的部分也是一样就是有这个互相竞争的一个状态下。另外在原物料的价格的上升各位也知道，在疫情的这段期间其实原物料一直上涨。各位从这个船运就知道了运输业整个船运大概涨了，至少有涨了10倍那这个运输涨价过程当中，其实会带动整个一个产业的一个价格成本上升，所以会造成整个产业的一个成本增加。那接下来我们产业的一个脉动会走向数位转型的一个状态其实我们刚刚已经知道，当整个世界的趋势，然后台湾的面临的一个挑战。那接下来整个市场跟所有的产业就会朝向数位转型。那在数位转型的过程当中，当然从最早我们从我们的个人电脑，然后网络时代到行动电话，到现在的数位经济。那数位经济现在大家可能拿着手机就可以去做结账做一些资料的传输，那这个部分都是属于数位经济的时代那包含银行的一些电子支付，这都是在数位经济 大数据的一个架构底下所建构完成的。那当然这个部分会牵涉到未来还有物联网5G 啊，虚拟的一个环境的一个结合所以这个产业跟未来的一个数位的一个竞争力其实是很重要的一个指标。像从最早的一个个人 PC 的时代到网际网络 Internet 到 Mobile 行动到数位经济那整个发展其实是一个趋势往上的。那最后包含像 IoT 我们现在如果以工业来讲，数位的时代就是 IoT 的时代。那这些网际网络的一些安全还有一些自动化的一些控制工控的部分，其实都是在未来发展上面很重要的。那智慧制造若以整个台湾的政策面来讲总共会分成5个应用层次那这个资料是由我们智慧机械推动办公室这边所提供的那我这边来跟各位做分享。那制造业有不同需求的程度那这边会提到是联网5个层次。第一个层次是联网化，那再来是可视化。那联网化就是先让我们的这些设备能够先联网，那联网之后再走到可视化。所以联网之后我们可以得到一些数据，那这些数据可以显示在我们的系统上面。那从这个系统上面我们就可以了解整个自动化设备或者我们的一些 IoT 等等，或者系统上面出现什么问题。那这些问题我们可以透过预测就预先诊断。那预先诊断的状态下，我们才可以去找到一个最佳化的一个解决方式。所以基本上我们会有几个步骤，就是从联网到可视到透明、可预测、知识化。那这个是属于智慧制造的一个进程。那透过这样的一个智慧制造的一个阶段性去创造我们智慧制造的一个价值。那接下来是整个政府政策的推动刚刚我们有提到，就是在106年，其实在政府这边有订定几个政策发展方向。那其中一个发展就是智慧机械。那智慧机械在产业推动的部分，其实它有几个愿景那包含推动智慧机械的一个自机产业化跟产业自机化这很饶舌就是自机产业化、产业自机化，那这2大愿景。那要符合这2大愿景，我们当然需要有一些政策来推动。那这个政策包含连结在地、连结未来、连结国际这3个层面。那在我国智慧机械发展的这个时候会有广度、高度跟深度这3个所以我们从这个轴向来看在广度的部分我们要做到自机产业化自机产业化。所以我们智慧机械要产业化，表示我们要首先让整个产业能够有基本的一些智慧功能。那这些智慧功能目前有一个新的方案是来自这个 SMB 智慧机上盒。因为有很多中小企业，它机台要把数据上传就会有困难。那你怎么让这些设备能够有基本的功能，把这些数据丢到网络上面那形成一个大数据的一个收集。那这个部分就有一个是智慧机上盒的一个建制，所以政府就在推智慧机上盒的应用那这个部分就是让我们国内的这些设备能够基本上能够先连上网。那连上网之后，我们才能够往后面的智慧机械或者联网大数据收集的这个层面往那个方面走。那接下来广度之后，还有一个纵轴叫这个高度高度的部分是产业自机化。那产业自机化的部分， 这边有几个计划在推动哦，包含智慧机械的领航计划。那这个部分是要打造我们这个产业哦，能够智慧化哦，智慧化的部分。那另外把智机产业化跟产业智机化合并之后，再往下扎根哦，那把这个整个供应链跟系统串联起来哦，变成一个有深度的一个智慧机械的一个发展。那这边有几个那个案例哈，那广度的亮点就刚有跟各位分享的哦，智慧机上盒的部分辅导的一个状态，实际上现在目前国内大概有7000多台设备已经装上这样智慧机械盒哦，那当然还跨了14个产业哦，超过300家厂商，那去执行这样的一个计划。那当然，这个计划会影响到整个产业的发展，因为整个在政策上面，当然这属于经济部的了哈，政策上面是这样的推动，那未来整个产业环境就会朝向智慧化的一个环境，所以后续的这些后续在执行这些智慧机械哦，还有在这个智慧机械环境底下工作的这些劳工。哦，他们可能会遇到的会有不同的一个层面的一个安全的议题，哦，就不是以前我们的这个传统的一个思维，那就包含像上一堂课哦，我们苏博提的这个人机协同的作业模式，那这个部分哦，可能就已经打破以前用围篱的方式来做一个防护，那会有更新的一些防护方式的一个议题哦，会出现。那另外一个高度亮点的部分，当然这个是在台湾的福特6合汽车，它打造了台湾第一条30秒快速切换，然后可以做4种车型的一个弹性的一个生产线，那这是一个案例，所以这也是一个弹性制造的一个议题，那弹性制造的议题里面的元素又会包含机器人跟自动化设备。那机器人跟自动化设备里面，机器人有典型的工业机器人，或者是人机协作机器人。那自动化设备里面也会牵涉到不同的这些输送带，还有一些自动化系统。那这些安全性，其实在未来也是一个议题。那在深度亮点的部分，这个部分就包含之前在智慧机械推动办公室这边有协助国内有一家厂商在做螺旋桨的加工，那他把螺旋桨的加工制程用智慧化之后，用 AI 机器人研磨抛光技术应用之后，那其实它提升了18%的一个效能，那这是一个案例。那当然在未来的一个政策跟做法的部分，整个政府的政策跟目标，其实基本上还是 focus 在智慧机械这个主轴。那一个政策2大推动方向。那第一个政策就是要打造亚洲高阶制造中心，这是政府目前的一个方向，就是核心的一个方向是目标是亚洲高阶制造中心。那2大推动方向要达到这样的一个目标，基本上我们要智慧机械，要智慧制造，所以会强化 AI 跟5G 的运用，还有智慧化的一个软体的结合，加上研发的创新服务的应用。另外有3项的一个具体的策略，政府这边在推动的部分，就是刚刚提的连结在地、连结未来、连结国际。那当然要连结在地、连结未来、连结国际的部分，那就必须要基盘的一个扎根深化跟服务的一个整合化、系统智慧化、云端化、平台国际化跟市场的全球化。当然下面还有很多的一些子项目，那这些项目主要在支持整个智慧机械未来在政府推动上面，让整个产业能够提升。那当然最后 这个产业提升很重要的未来走向 AI 跟5G 的科技，才能够打造台湾的一个亚洲高阶的制造中心。当然这是一个愿景啊。整个政府在推动智慧机械、智慧制造的一个愿景跟策略。那刚刚有提到的，就是整个愿景策略必须透过这一些整合，服务的一个整合，系统的一个智慧整合，那把主要的基础的工艺建制完成，那人才培育要一定的一个基础，那另外才能够提供一个国际化的平台去推动整个智慧化，那到云端未来走到云端。所以整个智慧机械基本上在我们的一个广度、深度、高度这几个结合之后，那在未来整个智慧机械希望借由基础的一个工艺，当然这个是比较虚拟的，就是说基本上我们在智慧机械推动办公室这边基本上就是会朝着产业的一个发展，那协助产业能够做到最基本的一些智慧化，那将这些智慧化的元素在往上让整个产业提升到一定的程度，那跟国际能够做一个连结。那上述是针对我们整个政府这边所订定的政策做一个说明。那接下来我们针对整个国际上面的一个验证的一个发展，做一个简要的一个介绍。那这个会连接到上面我们政府在定政策的时候，那包含未来在整个产业环境发展的部分，我们智慧制造安全要怎么走？当然，在传统的一个制造业就是人力密集，那接下来当然会走向自动化。那自动化里面包含自动化的设备，包含机器人。那当然最早从我们的就是用人力的方式，到未来的机器人的方式，或者走到更久的未来，那就是机器人来管人，机器人管人。那当然这个是某一天可能会发生的事情。那当然这样的一个状况，其实整个产业环境的变动，那整个安全性的一个防护也会不一样，考虑的层面也会不一样。那当然今天谈到很多智慧化的部分，那很多都是机器人。那机器人实际上在整个产业环境上面曾经有发生过很多的危害，也不是说机器人就不会产生危害。其实在国外有很多案例，包含在美国也发生过一些机器人的危害案例。那早期我们会认为说机器人用围篱围起来就没有事，那实际上其实不是这样哈。当然在维修保养的时候是最容易发生一些公安事件的。那所以在国外其实发生过许多的案例。那机器人基本上是应该说机器人是在自动化的设备里面其中一个元素。那在欧洲跟 ISO 的标准里面就有去定义这个智慧自动化跟机器人的一些安全标准。那当然在前面上一堂课苏博这边也谈到很多机器人的一些安全设计的一些要求，在10218之1跟15066的部分。那这个部分实际上它会连接到一个最自动化的一个标准是 ISO 11161。那这也是早上英国那位专家 Safenet Peter 所讲的 ISO 11161。那这 ISO 11161它是一份自动化整合的安全标准。那它谈的是整个自动化整合之后，它所需要的一些各层面的一些安全设计。那这些安全设计当然会连接到工业机器人，包含10218之1跟10218之2。那还有如果是人机协作的话，有一个15066的一个安全标准。那自动化当然不只是机器人，机器人以外当然会结合其他的一些 设备，工业设备。那这些工业设备也有它的自己的一个标准，所以会结合系列的机械标准。例如说，今天我的自动化设备有搭配机器人，那是架构在冲床上面，冲床的一个生产系统，或者架构在一个车床、铣床的生产系统上面。那我在考虑整个自动化的一个环境的安全的部分，那就必须全盘考量，全盘考量。那以往我们都会以机械安全当做一个思维，那机械安全的思维之外，其实未来有很多就是透过网络或者透过自动控制，那这些会经过一些传输，所以会有个工业治安的问题。那工业治安这边就会跑出一个 IoT 的一个议题，有一个62443的一个工业治安的一个安全问题，也就是今天早上第一个题目，我们新加坡的专家跟各位分享的部分。所以整个自动化设备其实除了机械安全之外，未来还会加上工业治安的问题。那另外当然还会有一些机械电的机电电控的一些问题，那是原本就存在的。那整个工业自动化整合，未来考量就必须要这样的一个基础，当做我们在设计未来自动化设备安全的一个参考标准。那刚刚有提到人机协作的部分，ISO 15066这份标准。那这里面有提到一些安全设计的一些概念，包含必须要有速度监控的一个停止、手动导引或动力力量的一个限制，还有速度或分隔控制的部分，这4个部分。那另外在人机协作的部分，那这边基本上要有安全功能的一个分析，functional safety。那其实走到不是只有机器人，未来在所有的自动化设备上面，其实都会靠系统控制。那系统的稳定性跟可靠度就是很重要的一个议题。那系统可不可靠、稳不稳定、会不会出错这个部分就有一套验证的机制。那这个机制就是 functional safety， 那就是安全功能，也就是我们常常听到的 IEC 61508。那如果 IEC 61508这个 functional safety 的验证系统再往下荡下就是 IEC 62061，那再往下走就是 ISO 13849之一。那这一连串都是属于在整个系统上面的安全可靠度的一个验证的一个标准。那另外有一块在机器人跟自动化需要注意的就是速度监控的部分。就是例如当我们在手动操作的时候，或者在维修的时候，人进到维修空间，那我们一定会把整个机台设备把它切到维修模式、手动模式。那这时候机器是可以动，但是它必须要受限，速度要受限，在某一定的速度底下做运动。那会不会爆冲？当然我们不知道。那它所靠的就是后面背后的这个系统的可靠度，你的软体写的可不可靠，然后你的这些整个系统的一个sensor，辅助去确认系统有没有突然做一些超速或者过速的一些状态，那这个就是速度监控的部分。那有些设计上面会透过一个速度监控模组，去达到一个监控的一个功能，符合整个国际标准的要求，那速度监控的部分是非常重要的。那机器人的部分，当然除了 functional safety， 这是在控制系统上面，加上速度监控之外，那有一个是在机械上面比较重要的，就是撞击的测试。当然，刚刚硕博这边有提供一些资讯，就撞击测试、能量测试。那当然，在撞击能量测试这个部分，就是要确保我们的机器人撞到人的每个部位，那人不会受伤，是可以承受这样的一个力量。 那当然 ，PMC 精密机械研发中心在撞击测试这边也有相当的一些研究。那后续如果说业者有需要的话，我们这边可以提供这样的一个服务能量。那 PMC 在机器人这个部分也成立了国内第一家符合 TF 的一个实验室。另外，在人机协作的部分，刚刚苏博也有提到佳士达的案例哈。那佳士达这个案例其实有很多单位一起共同来完成。那这个也是符合我们当初治安署这边在订定机器人的一些安全防护的一些要求。国内第一个算是符合治安署的要求的一个示范线哈。但这边有一个议题，就是原本我们的在设计安全的部分都是以单机安全来考量，那目前走到智慧化、自动化之后，会以厂区的安全，就是整厂的一个安全的一个设置来当做一个考量的一个点。当然这边就会引用我们刚刚提的工业机器人的危害预防标准，还有包含像 ISO 10218之1之2，还有15066。那包含像刚刚提的有一个 ISO 11161自动化整合标准。那这个部分都是属于智慧自动化未来所需要去符合的。那这里面还有一项比较特别，就像 AGV 加上我们的 Robot。那这个部分在高科技厂是最多。台湾其实现在的护国神山就是半导体。那半导体的部分其实厂内目前都是人力精简。那人力精简状态下，其实像这种 AGV 加上 Robot 去协助做一些 wafer 半导体的晶圆的搬运的部分，其实是几乎每个厂都有。那像这样的一个自动化，实际上它也有它 AGV 的一些安全要求，包含 AGV 它有一些碰撞测试，还有它行走的路径到底有没有按照你原本的设计的路径去走，这都有一些安全的一些要求。那这也是在这一次佳士达认证里面也有的。那当然在佳士达这个案子里面，实际上我们是执行了相关的机器人跟 AGV， 还有包含像苏博这边的这个皮肤电子皮肤的部分然后共同结合起来去完成这样的一个认证。所以当初在报道这边新闻报道这边也有特别提出全国第一例佳士达完成这样的一个示范的一个案例。那这个影片刚刚那个苏博那边有播过了主要是这个部分就是当我人去触碰到，应该说人去接触到这个光栅，那里面的这个机械动作会放慢速度那如果更接近可能是停止，或者碰触到的时候，碰触到电子皮肤的时候就是停下来这是最重要的一个安全设计。那这样的一个安全设计也让整个自动化的产线其实它的人力降低然后它的一个生产效率提升那整个自动化1161 ISO 1161自动化整合安全标准里面，它有提到一个名词叫 IMS 就 Integrated Manufacturing System， 那就是自动化整合的系统。那这自动化整合系统里面就包含了机器人，包含了 conveyor， 包含周边的这些设备串起来的系统就叫 IMS。那这样 IMS 的一个架构，就是未来在智慧机械的场域会经常看到的。那这样的场域就必须要去符合各方面的一些安全认证。那当然基本上包含最基础的机械安全，还有一个电气安全，那电池相容安全。那电池相容安全其实平常比较少人会去注意，就是电磁干扰干扰的部分。其实机器人或者自动化设备 它有可能受到我们外部环境的一些电磁波去影响它，可能传递讯息的时候，就中间就 lost 掉某一小段的讯号，或者受干扰之后，传递的讯号是不正确的，那这个部分可能就会产生误动作。所以这个是电磁干扰测试，其实在未来越来越多依靠我们电子传递讯号的这个设备的一个状态之下，是越来越重要，越来越重要。那另外一块是工业治安，就是我们讲的 Cybersecurity 工业治安的部分。但传递的过程当中，另外一个就是软体的一个可靠度嘛，那会不会有骇客进来？那其他的这些资讯安全的问题，那这个也是牵涉到安全智慧工厂未来是否足够安全的一个状态。那另外一个是功能性安全，刚刚也有提到 functional safety 的部分，就是整个系统会靠我们的自动化控制去达到一个安全的状态。例如说以前我们设计是双回路，那双回路可能不够，需要经过安全模组 safety relay， 那现在可能又开发出新的，就 safety PLC。那这样演进下来之后，那这个 safety PLC 它就相当重要，因为它是安全的核心。那这个安全的核心，它到底够不够安全？那就会经过验证，那这个验证就会指引到 functional safety， 就是61508。那这个可以追溯到更多产业。其实 functional safety 其实它是一个母法，那架构下来，它包含像核能产业，我们会担心核能发电厂会发生问题吧？那你怎么确保核能发电厂这些控制系统没有问题？它就是由 functional safety 功能性安全这边延伸下来的一整套的一个验证手法，去确保。那轨道车辆会不会有问题？也有可能。我们刚好在高铁旁边，高铁的可靠度够不够？那 functional safety 里面就有一套轨道车辆的一个验证手法。那机械安全设备也是，自动化设备也是，其实都架构在 functional safety 底下。你的这些控制系统必须要符合一定程度的一些安全可靠度。那经过这样一套的一个认证，所以基本上在智慧整合系统里面，未来的一个发展趋势，建议必须要符合功能性安全、机械安全、电池相容跟电气跟工业治安这样的一个安全架构底下，能够达到比较安全的一个工作环境，让我们最后的目的还是要让我们劳工在安全的环境下工作嘛，所以基本上就必须要有这样的一个认证的一个机制，能够让我们员工能够工作得更安全。那在整个全球的一个验证的一个趋势里面，实际上未来其实除了安全以外，应该会走向什么？绿色环保。当然这是另外一个议题啊，因为目前其实碳中和的一个议题炒得很热，包含现在我们的一些工具机厂商、机械厂，还有台积电，包含美国的 Intel， 我们都已经接受到很多讯息，就是希望能够做一些节能减碳的一些认证。那当然这个从最早的设备安全，欧盟的 CE 认证，到英国现在有个 UKCA， 因为英国脱欧之后自己又独立弄了一个认证系统叫 UKCA， 那另外在国际半导体协会有一个 SEMI-S2 的一个半导体认证，那这个部分实际上在国际上面走完安全之后，最后可能又会往绿色制造这个方向去走，所以未来可能是安全跟绿色 两个会密不可分，两个是结合在一起。那国内的部分也是，国内其实很早，很多我们的高科技厂自己就开始自己推安全的一些机制，包含早期的奇美，也就是现在群创，他们自己设计了高科技设备的安全规格书，所以所有的设备卖到群创、奇美里面，他们自己有一套验收系统，在验收这些设备。到底机台有没有符合双回路的设计？那你的机器人有没有符合国际标准？有没有一些安全设计？然后你的安全护罩、你的人因工程等等，到底有没有符合？包括你的电控系统有没有符合电工法规？这个部分其实在很早在高科技厂就已经开始走了。那包含今年其实汉语彩晶也开始走这一套系统。那如果在半导体的部分是走 SAMS2， 包含台积电、联电等等，其实有一套 SAMS2 的安全认证系统，所以所有的设备要进到高科技厂里面，就要符合 SAMS2 的认证。那当然这里面有一整套的，包含自动化设备、它的化学品的安全，还有一些气体的泄漏，那包含人因、包含火灾、爆炸等等。都是在这个半导体 SAMS2 认证的一个范畴里面，所以实际上在产业这边，产业自己都已经有开始跑在前面，已经开始要求它的设备商必须要符合一定程度的一些国际安全。那当然后面我们提的未来绿色制造的部分还是会有，从去年台积电他们已经开始喊出除了安全之外还有绿色制造，所以有一套绿色制造另外的验证的一个机制，所以国内最后除了安全之外，其实会往绿色制造这个方向走。那精密机械研发中心实际上在安全验证技术上面大概已经有20几年。那从最早我们从事工具机工业机械安全，那协助国内的厂商去符合欧盟西那包含还辅导我们国内的高科技厂包含群创、奇美、友达光电等等，这些制定他们的一些安全规范。另外在台积电的部分，我们是台积电的第三公证单位，也是美国 Intel 的第三公证单位，协助这些高科技设备能够符合这个国际安全标准。那另外在产业的部分，我们也担任过这个中钢的顾问，协助中国钢铁去建制他们一整套的设备安全的一个标准。那他们说采购的所有的设备都会透过这样的一个机制去执行验收，去确保这些设备都有一些安全功能的一些设计。那另外在政府计划的部分，当然我们也执行劳动部职安署还有其他部会的一些计划。那当然在未来除了安全之外，还会走向绿色环保，当然这是一个趋势。那基本上从早上的一个Cybersecurity 的议题，一直延续到下午机器人等等这些安全的议题。大家也知道，整个产业环境实际上都是往智慧机械这个方向走。那未来在智慧机械这个领域，实际上还有很多的一些安全议题会发酵。那经过一段时间之后，这些标准可能又会再重新修改。所以其实每年我们应该会有很多不同的研讨会在分享这些新的安全的设计跟安全的一些要求。那未来在智慧机械这一块，其实我想台湾是一个机械，算是一个机械，要讲大国吗？好像刚刚看起来也不算机械大国，但是是在世界上至少是一个很重要的机械出口国。那 进口国也是算也排名在前面哈，也是进出口都是，所以这个部分实际上在未来整个产业环境上面，我们如果以劳工安全当做一个思考主轴的话，那智慧机械希望能够让劳工更安全，那能够在更轻松的一个环境之下，然后产能更高的状态之下，那也为我们产业去带来更好的一个经济效益，然后劳工的一个治安的一个事故能够降低。那今天报告到这边，谢谢各位。
好，我们也用热情的掌声，非常谢谢李医生处长的一个分享。那他也提到了很多在工具机械安全还有设备安全等等这个验证上面的一些案例跟内容。那我们今天的研讨会，简单来讲，哇，从早上到现在，其实也是一个接一个，非常非常的紧凑跟精彩。那我想今天也非常感谢大家陪伴我们一整天哦，从早上到下午的时间。那如果说会后大家有什么样的疑问，或者是说想要进一步的来跟我们今天两位现在下午正在现场的两位讲者进一步的来分享的话，那也大家会后都可以多多的交流。那我们今天的国际研讨会就到这边告一个段落，也再次谢谢大家今天的参与，谢谢。